Hey everyone, a very good afternoon, and thank you so much for joining in on a Sunday afternoon. I heartily welcome all of you to this event. So, in today's event, we have a very special guest with us, Sayan Day. So, Sayan has over a decade of experience working in the data science domain. Currently, he has been working with Walmart, and Sayan also has been a visiting faculty at multiple prestigious institutions like Great Lakes and IIM Bangalore as well. So, yeah, in today's event, we will be learning about how machine learning is utilized in fantasy gaming like Dream11. So, right now, since the IPL season is ongoing, a lot of you must be using Dream11 to place your bets on certain teams. So, we will see that how does that work in the background using machine learning. And towards the end of this session, we will be having a quiz. And the winners of those quiz will be getting some exciting vouchers from Team AlmaBetter, and at the end, there is another surprise waiting for you. So hang on, sit tight, and that's all from my end. I'm also hoping to learn a lot about machine learning in this event. So yeah, over to you, Sayan.
Thank you so much. Thank you so much, team, and it's wonderful to have got the opportunity to be presenting in front of all of you. Uh, we've been doing these master classes for a while, and I think it's definitely amazing to see all of you coming in big numbers on a Sunday evening and attending this session. And really excited to be talking about something very close to my heart. Cricket is a sport that I'm very fond of. Although Dream11 can be used for other kinds of sports also, and I'll introduce that a little bit as well. But really excited to talk about it. So just to give all of you a little bit of brief in terms of how the session agenda will be organized, we will come to the specifics. Here is a small profile about myself. The team and Rashmi did a wonderful job in introducing me. Thank you, team, once again. So just a very quick agenda with respect to what we will do and how we will drive the session here. So we'll just quickly take you through that part here. So this is generally what we'll talk about. We'll start with a very basic introduction to what is Dream11. Now, of course, we are assuming everybody knows what it is, but still we might have some of you in the audience who have absolutely no clue about what is Dream11. So we'll quickly take you through the platform and what it is, and we'll take you through some of the pieces of Dream11. And we'll understand what is fantasy gaming, what kind of a platform it is, a little bit of basic introduction to the platform we'll have. Then we'll come to use cases of machine learning and AI at Dream11. So the organization as a whole, there are many partner companies they also have. So I think Dream11 is the one that we typically hear a lot, but there's a lot of other partner companies they have like FanCode, DreamX, and all that. We'll try to understand how specifically they are applying AI and machine learning at the organization. So this also we'll discuss at a use case level initially. And from there, after discussing those 3-4 use cases, we will come straight away into how they implement those use cases. Like, for example, recommendation systems is right at the core of what Dream11 does. Next time you're trying to pick up the favorite team who will win the IPL match, I believe today, let me just look it up. I think today we have this one. Tomorrow we have this one, sorry. 7:30 p.m. we have Rajasthan Royals versus Sunrisers Hyderabad, right? I think tomorrow we have Calcutta Knight Riders versus Punjab. So I also have Dream11 this one open in my mobile. So I think unfortunately, I think it's the app basically. It'll be hard to probably show you everything, but I'll try my best to show you some content. So the idea is how do you go back and pick up the pick up the best team out of the all the individual players. So we'll look at specifically how the recommendations are happening. The Dream11 does have a lot of sophisticated algorithms using which they try to recommend you the favorite teams. What kind of players will perform well tomorrow? What kind of players will perform? So that we will see the specific techniques. And as we discuss those topics, we'll get into specifics of some algorithms like what is a neural network, what is a regression. So we'll try to give you some basis into how these things are happening. We won't make it too detailed. I will not make it too dry and too technical. But at the same time, one of the things that I will ensure that you get out of the class is some key takeaways, not just an empty blah blah about hey, this is player Andre Russell and this that. We all know what machine learning is and use cases. But one of the things that we try to do very differently in the master classes is we also try to tell you specific ways how these things are achieved, not just the use cases, but the specific ways, which we'll come back to the end. And the last 45 minutes, half an hour of the session, we'll be focusing more on AlmaBetter, what we are doing very differently in the organization, And that part is very important because obviously I'm sure people will want to know. So that part will come back to the end of the class. We'll do some Q&A, and we'll also pick up some specific questions you have with respect to AlmaBetter, what we do, the programs we do very differently, very uniquely compared to what anybody else in the industry is basically doing right now, and how we as industry experts, we help in the program overall. Okay, fine. Let's get going. Shraddha, we'll see. I think we'll speak to the team on that one. Okay, I think we'll come to those specific queries in a while. So what is Dream11? Before I get into this, how many of you have actually used Dream11? Let's have a show of hands. If people can ping on chat. So please type everyone so that all of you are able to know each other. Like, how many of you have used Dream11? If yes, no, you can also ping a no. So just make the Zoom to everyone and then you can ping. So that way everybody will know what each other is responding. Okay. Okay. Chirag has also used, Rhea has also used. Okay, wonderful. Aisha has not used. Okay. Anybody else? And maybe if you're saying yes, you can also specify under what category you used. Now, I might be very biased towards cricket because I love cricket, but mind you, Dream11 is not only for cricket, but they have fantasy sports platform across other games as well. So they basically have cricket, football, basketball, and other games also. So not just that cricket is the most popular game, but then we have cricket, football, kabaddi, basketball, baseball, handball, and volleyball, to be specific. So in the platform, there are basically total 7 games that are listed out. And the idea of the platform is that it helps you to pick up the best team. So like, for example, today evening, we will have Rajasthan Royals versus Sunrisers Hyderabad. So what you will have to do is you will have to invest some money. You will basically put in virtual money on the platform, and using virtual money, you will basically select your favorite team. You select your favorite team, and you'll have to pick up a team of 11. And there are different criteria. They will have how many batsmen, how many bowlers, how many foreign players will be in. So you'll basically pick up your favorite team. And if those players perform well, if the captain performs well, if the vice captain performs well, all those criteria are there, you basically get points. So you pick up a team in advance. There's a particular cutoff that you will also have, by which time you have to pick up the team. Obviously, you can't select players during the match, then you will get to know. So before the match starts, you have to complete the team selection. And based on the team that you selected, based on how those players are performing on the stage, you get rewarded with points. And those points will convert to real money at the end of the match. So this is how the fantasy gaming platform basically is created. Now, Dream11 is not the only company. There is a lot of interest that we are seeing in the whole fantasy gaming space. But mind you, there are a lot of legal regulations around it. Like I think, again, that's a very separate discussion around it. So this is, and I won't call it gambling. I won't call it betting, but I think, in India, there are certain states where you cannot. Like if you're participating in Dream11, then they will ask you for a consent form that you're not in any of the states which block it. Like I think there are some states which technically block you from participating in these kind of things. So it is as good as a casino. Think of it that way. Right? Just that you're using some amount of knowledge, some amount of domain knowledge and data science and all that. We'll talk about those parts, but it's what basically the platform is. I hope the idea of Dream11 is clear. People who are completely new to it, I hope you now understand what Dream11 is. So you put money on players, and if those players perform well in the real world, then you actually get points, and those points convert to real money. So that's one way to look at what the platform is basically based on. Okay, so and it became a unicorn. So April 2019 is when Dream11 technically became a unicorn. And if you look at the valuation, I would say 2021, November 2021, Dream11 was valued at $8 billion. It's a very valuable company, very profitable company, mind you, because the fantasy sports, technically, apart from the investments they put in infrastructure, there is almost no cost involved as much, generally speaking. And as of December 2022, latest data, if you see, as of December 2022, Dream11 had 160 million active users in India. Okay, so how many? Okay, just a minute, Aisha, Aziz, sorry, thanks for mentioning that. Just a minute. Let me see if I can increase my microphone volume a little. I think this should sort it. Is it better? I think this should be a little better now. This should be a little better now. Yeah. I hope it's a little better now. Huh? Yeah, I think it was a little low actually. I went to Zoom and I increased that. Thanks for letting me know. So as of December 2022, Dream11 had 160 million active users in India. So India is a population of approximately 2 billion people. And you can already see 116 million active users in India. That translates to, like, you can look at the numbers, like almost 10-20% of the population is in Dream11 already. That's actually incredible. This is just a massive scale of fantasy gaming, what it is and what it actually does. Okay. Just to give you some basic context around the platform, it was founded in 2008. So 2008 is when the platform was basically founded. So it's been quite a long time, and there are a lot of investors that have in the platform. So they get multiple rounds of funding. You can look at those technical details as well. And but then it's a very big platform overall, and it's an extremely popular platform overall. Now, with that in mind, let's come back and talk a little bit about the use cases. I think we talked about fantasy gaming already. What is fantasy gaming? So the whole idea is, and please remember, one very important thing is that you need to have knowledge in sports. Like, although we are discussing this topic of Dream11 in the context of machine learning and AI and data science, mind you, if you just have technical knowledge, you can't do anything. Because team selection, yes, you will use some of the techniques of machine learning, some of the techniques in Python. We will discuss some aspects of those things as well. But hey, if you don't know what is a batsman and what is a bowler, Python will not help you learn that. Right? And I mean this in all seriousness, that data science, AI, machine learning, you'll be successful in this field only with domain knowledge. If you only come across as somebody with a huge amount of technical knowledge, you know a lot about coding, you know everything in Python, you know all the technical skills, but you don't even know what is cricket. What Dream11 will you play? Boss, you need to know how to select players. You need to know what kind of constraints to apply. Now, there are very clear constraints in team selection that you need to have one wicket keeper. Now, you don't even know what's a wicket keeper. So you tell me what Dream11 will you play? So I'm mentioning this point because this is often a very key question people typically ask as well. That, sir, how relevant is domain knowledge, especially for freshers, people in the audience who are joining in? Domain knowledge is extremely important in data science nowadays. And this cuts across whatever organization you're working for. Even if Dream11 hires you, you can't go to the company and say, I don't know anything about sports. I don't watch sports. So they will look for sports enthusiasts. If there's actually part of their hiring criteria also. So very interesting. Basically, there's a wonderful blog where I wanted to just show you. This is a blog that was, this was in 2021. And this is basically by Mr. Amit Sharma, the CTO. Okay. So Amit Sharma is such a chief technology officer of the company. And I'll share this link with all of you. So he's the CTO of the company. And Amit Sharma actually talks a little bit about what kind of talent they're actually looking for. So what kind of talent that they are looking for. You can see what kind of skills do you look for while hiring data scientists. So one of the most important things that you will see is we look for talent who share a passion for sports. That means domain knowledge. So in an interview at Dream11, you will not only expect questions with respect to, let's say, a Python or machine learning or some of the skills that you'll be learning with us, but also the domain itself. And this cuts across whatever industry you're actually joining. So even if you're joining something like, let's say, a Walmart will expect you to have some knowledge of retail. If you work for an Amazon, your chances of getting selected in Walmart actually increases. In fact, a lot of Walmart people leave for Amazon. A lot of Amazon people leave for Target. So cross-industry, similar industry movements are very common. If you're working for a telecom company, if you're working for a Reliance Jio, then the kind of problems that you're solving there, let's say tower infrastructure problems and some interesting ML problems that you're solving there. Let's say you're trying to basically optimize the signal. We see a lot of call dropouts are happening, right? So even in Jio, I can see last few days, I don't know, maybe it's in my circle, but I'm seeing a lot of call dropouts are happening. So this is again an excellent AI problem. How do you predict which tower I'll be connected? How do you minimize the call dropouts? These are excellent machine learning based problems that are there. So to solve these kind of problems, you need to have domain knowledge. If you're working for a financial company, let's say you're interviewing for American Express. If you're interviewing for American Express and you're asked a question, you will be expected to have some knowledge of the business. You should know the retail business, what kind of products they have, what is a customer loan, what is the process of approval of a loan. You can't just say, I just know Python and that's it. Okay, just wanted to specify that part because oftentimes this comes across in the conversation that how relevant is the knowledge of sports, especially in the context of what we are talking about. Very relevant, very important. You need to really be passionate about the domain that you're involved in to really make a mark in the field. Okay. Okay, now moving on, what type of problems are we solving at Dream11? Like how is machine learning actually used in Dream11? And what type of specific machine learning based problems and AI problems are we solving? What kind of prediction problems are we solving at Dream11? So one very common, one very obvious prediction problem that the platform is basically doing is player performance prediction. So obviously, when we're talking about selecting today's team, Rajasthan Royals versus Sunrisers Hyderabad, that will happen at 7:30 p.m. We have to So the platform, while selecting the team there, I think again, it goes for people who have actually used Dream11 extensively. So while selecting the players in the platform, you get a very clear option there where you can say that, hey, like the platform will recommend players to you. Okay, the platform will basically recommend players to you based on who they think are right. So the platform will also give you recommendations. And this is basically done as part of user engagement, right? It's almost very similar to how Hotstar will recommend content to you. How when you go to Netflix, Netflix will recommend, hey, Sayan, I think these are movies you might want to watch. Now, whether you want to watch the movie or not, that's up to you. But the platform will give you some recommendation. They think that, okay, this player might do well. So let me show this right in front of Sayan. So let's say if you're having somebody like an Andre Russell, like nobody will want to leave him out, right? If you're having Virat Kohli, like Kohli is something you will not leave out, right? If you're having, let's say, back in the days, I was a Chris Gayle fan. See, I mean, I have this thing for West Indian players. Like they are big six hitters. Like I'm a cricket fan. Who doesn't like big sixes being hit, right? So I'm a big fan of West Indian players. Okay, I don't know how many in the audience are, but I have a clear bias for West Indian batsmen. Like players like Chris Gayle, Andre Russell. Any other names you can give me? Who are the top West Indian hitters? Huh? So I think any of the top 6-7 batters, if you see in West Indies, they're all huge six hitters. Any of the major international Premier Leagues that are conducted, T20 leagues, all the West Indians are typically there. Pollard, yes, how can we forget Kyron Pollard? Like other players, doesn't matter. West Indian batsmen will always make a mark. Even I think the Australian T20 leagues that happen, there is something, the Bangladesh league, I think, if you know, Chris Gayle was also a part of it, BPL. So yes, Dwayne Bravo. We have Dwayne Bravo. We have got the other one. I'm just forgetting the name. Dwayne Smith. We have got Kyron Pollard, Chris Gayle. Who can forget Andre Russell, right? So huge hitters. Are we forgetting anybody? I think other than that, yeah, I think there are a few others. I think there's the one more left-handed batsman. I'm just forgetting the name of that left-handed batsman. Again, a huge six hitter. Left-handed. How can I forget? Come on, somebody give me the name. No, hey, Nareen is a bowler. Yes, he's a bowler. Of course, he's one of the most economical bowlers in T20. But who is that left-handed six hitter? I'm just forgetting the name. Anyway, so yeah. Okay. Anyways, so just wanted to kind of mention that. Okay. So player performance prediction is a very interesting problem where you're trying to figure out which of the players will perform well, and the platform will give you recommendations, and they will basically help you predict that, okay, the performance of the player will be so and so. The player is likely to score so and so runs. The player is likely to get so and so points. So you look at the historical performance of the player, and based on the historical performance of the player, the model will predict how the player will perform. That is a very common problem, and how it happens, we'll give you some technical details in a while from now. Another very interesting kind of problem where Dream11, the platform, the app, the application that I have opened right now on my screen, you're able to see, I think it's a little vague, but the application that I've opened. So this platform, it also uses a lot of this so-called user behavior analysis. What is user behavior analysis, guys? User behavior analysis means it will look at the user who is joining and browsing the platform. So if I'm the user right now, it will basically look at the user who is browsing the platform right now. So who is the user who is browsing the platform? And it will analyze the behavior of the user and give proper recommendations. So this is also an excellent, so this and this are kind of correlated. User behavior analysis and real-time recommendations, kind of correlated use cases. So recommendation system is right at the center of what Dream11 is trying to do. So next time you open an account with Dream11, you log in with your mobile number and your Google account. The very first thing that Dream11 will try to do is try to give you recommendations. So how do you know, hey, today there is a match at 7:30, I have to pick up a team. You have nothing at your disposal. Dream11 will straight away, right from the day one, it will start giving you recommendations that, hey, these are the players that you can start with. And then you can start racking up points. So you can do a fair amount of this so-called user behavior analysis. And recommendation systems is another very, very central use case of what Dream11 is trying to do. Okay, so player performance prediction, recommendation system. And I'll talk about these more technically in a while from now. Fraud detection is also a very important use case where you're constantly trying to build models to detect fraud. If there is some kind of fraud or some kind of suspicious activity that is happening, these are all very, very common types of models. And I think this goes right in line with use cases pertaining to, let's say, something like a transaction fraud, credit transaction. Okay, so you logging into Dream11 because it's a betting platform, it's a casino, right? So what is the, like, There can be multiple users who try to sign in. They try to place multiple bets. The same user is trying to place multiple bets. There can be frauds. There are ample avenues for frauds in casinos and betting fantasy platforms. So how do you minimize those kind of frauds? So how do you minimize those kind of frauds? So how do you detect those kind of frauds in advance? Okay, so that's again a very interesting use case that is trying to solve. If I have to talk about one more very interesting use case where Dream11 is actually working in a big way, they actually use haptic. How many of you have heard of haptic? Haptic is basically, so just to give you a little bit of context, haptic is basically an organization that is into conversational AI. It's a company called Haptic. It's an Indian conversational AI platform. Very, very popular, very, very good, wonderful platform, which is basically, which helps you to kind of, like drive user engagement. The next time you reach out to customer support, it's almost like a chatbot will respond to you, something of that sort. See how cool it is. I need to reschedule my appointment. They have WhatsApp integration also. And the chatbot will automatically tell you what's the time. And it will give you some basic responses. If you say, I'm looking for a dress in Instagram, it will tell you, hey, this is what we think. So Dream11 actually uses haptic services. So the customer support, the whole customer support of Dream11, they use haptics conversational AI platform. And they also have some of their own add-ins that are added in there. And using that, the customers are able to get real-time responses to queries. Okay, almost like, let's say, because something people can relate to more in a better way. Let's say Swiggy, your order is delayed, right? So if your order is delayed, what do? You go to My Orders help support and you say, my order is delayed. And instantly, the chatbot sends a response to you that, hey, the order will be is on time and it will be arriving. Okay, it will instantly send a response to you. So this is the kind of thing that Dream11 also does. And there are some very basic queries that people will often ask. Like, hey, when is my, why are my points less? Why did I not get the points? Basic transactional queries that users have. You don't want to raise a support ticket and then reach out to them after 1 day, 2 days. Because oftentimes the customer, when the customer is at the center of the conversation, you want to make sure their basic experience is good. Especially with respect to conversational transactional queries. You want to give them a quick quick. That's one of the ways you can actually go back and do the whole thing. Now, if you go back and look at this is one more wonderful use case of what Dream11 is trying to do. They're trying to use haptics conversational AI platform, and this overall domain is what we refer to as NLP. NLP stands for natural language processing. And there are millions of users. I think we already looked at the numbers. There are, let's say, 200 plus million users that are active on the platform, 100 plus million users active on the platform right now as we speak, more than that, 150 million approximately. And these users are constantly posting stuff on the chat. They're constantly posting on comments. There are hundreds and thousands and millions of comments that are being posted every single day. And how do you go through that entire unstructured text data to make sense out of it? What people are feeling? How do you drive some information out of the online chatter? What are people talking about? What do they think? What are the next thing we should do? Are people happy? What are people commenting on? What are people commenting about? What are the key topics people are talking about? So these are excellent use cases of natural language processing that Dream11 is also trying to drive. And you might question me that what are we trying to achieve out of this? The primary thing that we are trying to achieve out of this is user engagement. Because if you're able to look at a huge amount of customer data, if you're able to see what kind of stuff Sayan is posting, and if you're able to see what kind of things Sayan is commenting about, next minute Dream11 can reach out to me and say that, hey, Sayan, I think you talked about this particular topic. You gave this particular comment on this particular thing. So will you be interested in this? So we can drive user engagement in a better way. So by understanding the real-time behavior of a customer, Dream11 is trying to drive user engagement in a better way. And this is just another wonderful use case how it is used, apart from the normal use cases of player performance and user recommendation that we are trying to do. Okay, so these are some of the general use cases I wanted to talk about with respect to what Dream11 is doing. Now we come into the next phase of the conversation, where we try to get a little deeper as to exactly how these things are happening. This conversation will be slightly technical and also use case driven. So again, when I say technical, I don't mean to say I'll teach you real topics, but it will be slightly more detailed and slightly more technical. So for example, when I'm talking about a recommender system, we'll see exactly how these recommender systems are getting built. And specifically, Dream11 uses something called a collaborative filtering technique. So we'll see what these things actually are. So we'll start our conversation with this thing. Okay, we'll start our conversation with basically collaborative, or let's say we start our conversation with player performance prediction. How does Dream11 use models to predict the performance of a player? How does it actually do player performance prediction? What is the idea behind it? So let's take a simple use case here, where we look at the historical data, and based on the historical data, Dream11 uses something like a regression. Basic regression models are actually used to predict the performance of a player in upcoming matches. Let's say today there is a match that's going to be played. So how do we go back and use basic regression models to predict how many points will be scored by a player in the upcoming match? And that's a very clear use case of a prediction problem that we are trying to solve. And I'll talk a little bit more deeply about this thing. And before we get into that, we will spend a little time understanding A, what is regression? B, how do we solve this problem? What is this line that we are getting? And what are the technical details behind what we are trying to do here? Okay. Before I get into this conversation, how many of you have seen this kind of thing before? And I'll also try to show a real use case as well. How many of you have seen this kind of regression kind of thing before? Anybody's heard of it? Quick show of hands. Anybody's heard of regression? No, nobody? New to regression, all of you? Okay. So I think before we come to this, let's do one more thing. Let's do one more thing. Okay. Let's give you a little bit of sense. Let's give you exactly just a type of supervised learning, correct? Let's give you a little bit of sense into what we are trying to do in the overall data science workflow. Let's quickly see that part as well. And before I start my conversation, let me just quickly take you through this part a little bit, and then we'll follow this entire life cycle with respect to the regression problem that we are trying to solve. Let us quickly see this one here in action. All of you give it a read once before I start discussing this. I'll encourage everybody to just give it a read once. Everybody, just give it a read once. Just give it a glance, and I'll talk more about what this is. So you can see this is a set of 9 different steps that we have right now. And right up front, we have something called data discovery. So this is one of the most important parts of what we are trying to do. First, we are trying to do data discovery. Then we are trying to do data ingestion. So what we are looking at right now are the different phases of a typical data science lifecycle. Okay, these are the different phases of a typical data science lifecycle. And before I start talking about data science, because we are actually entering into a specific data science problem, player performance prediction, let's try to understand a little bit about what is data science. When we talk about data science, what is data science? What are we mentioning? Because all these use cases that we talked about at Dream11, starting right from recommending which players to select for today's match, what is the performance of the player going to be in today's match, what kind of comments people are giving, the haptic conversational AI that we talked about, customer support, how do we automatically give answers to people's questions? So how do we go back and so all of these use cases that we talked about right in the initial part of the session, all of these use cases are part of a larger gamut of data science, what we are trying to do. So now the question is, what is data science? What do we mean by data science? So data science effectively is a set of tools and techniques that we leverage to convert the raw, dirty data into information or insights. So what is data science again? Data science is basically a process. It's basically a set of tools and techniques and methodologies that we use. It is again a set of tools or techniques or methodologies that we use to convert the raw, dirty data into information or insights. That is one of the things that we are trying to do as part of data science. So how do we go back and convert the raw, dirty data? So whatever raw, dirty data we have, how do we convert the raw, dirty data into information or insights? And that's what we do as part of data science. And these are the different
And if you think of it from the context of Dream11, if you think of it in the context of Dream11, specifically the beautiful use case that we talked about, player performance prediction, you can see, and we'll talk about regression in a little bit more detail. But the use case that we have is quite simple. We are trying to predict the performance of the player today based on their historical performance, weather condition, and other factors. What other factors are we talking about? If you look at it specifically, we are looking at predicting the performance of the player in today's match. That's how we are recommending the team tab to be picked up based on all these factors. This is what constitutes the raw dirty data. So what you're seeing right now, these features, this is what constitutes your raw dirty data. We have a ton of historical data with us right now, how the players have performed historically in the past. We also have the recent form data. We have the form data. We know what is the recent performance of the player. That is actually kind of like a historical data only. We also have weather condition data, like today, wherever the match will be played, what is the temperature going to be? Will there be dew on the ground? Because historically, if certain players perform very well in dew conditions, then will the same players, how well will they perform today also under the similar weather conditions? If there's a cloudy weather, thunderstorm is likely, then what kind of predictions will happen there? There can be certain players who play typically, inherently, they play very well in under certain conditions, right? Weather conditions were actually an extremely important factor before, but nowadays in modern cricket matches in T20 especially, it hardly matters honestly, because pitches and the overall thing is a lot more advanced. Technology has advanced a lot, but it used to be a massive factor historically, where even the slightest of changes in weather could very drastically alter the pitches. I mean, people who know a little bit of cricket, like how swing actually kicks in. The bowlers get to enjoy low scoring games typically with a lot of swing in the track. Those kind of problems actually happen. So slow tracks, like there's a lot of spin kicking up. So those kind of things are actually matter. But I think, as I say, nowadays with a lot of advanced, because see, IPL games are geared towards batsmen. Okay, let's face it. People, I think that's a bit of a bias. I know. I know we shouldn't be talking about it, but because otherwise nobody will want to be a bowler, right? but I think IPL is very biased towards batsmen. Like people come to the cricket ground to watch sixes, right? Including me. I'm also probably biased towards batsmen to some extent, but nobody wants to come to an IPL game to see bowlers picking wickets, right? So I think that's part of what it is. So I think even the whole idea around pitches and how pitches are laid out. So I think there's a lot of focus on quick, fast, bouncy tracks, where batsmen get the ball on the bat and they can hit sixes, not slow tracks. Okay. Again, coming back to the idea of data science, what we are doing. So we are basically using the raw dirty data, the data that is available in the form of historical performance, recent form, how the players recently performed, weather conditions, weather condition data, weather data we also have from some APIs, public APIs we will have, and we will have access to weather data. We'll have player matches, player matchups, and finally venue analysis, where the matches are being played, what kind of historical things we have. And based on all these factors, we are trying to predict the performance of the player. And that's the crux of what we are trying to do in data science. Data science, if you look at it, is the process of taking the raw, dirty data as it is available in different sources. It is using that raw, dirty data, and we are converting that data into information and insights. So we are using this entire information to predict the performance of a player. And ultimately, we will use that player performance prediction to figure out, we'll ultimately use that player performance prediction to figure out whether we'll use that particular player performance prediction to get some insights, like which is the best player to pick up and things like that. Okay. Now, just to give you a little bit of context with respect to how we go about this thing, and I'll try to take you through a couple of very interesting types of problems here. I know I talked about a few, because since we are talking a little bit about what we are doing in data science, I wanted to quickly give you a couple of very interesting problems, and one will be the Walmart use case. Look at this one, very interesting. We're looking at a specific use case at Walmart, where this was a competition that was hosted almost 9 years back. So Walmart Labs actually hosted a competition almost 9 years back, where they tried to use the historical data, historical store sales data, to predict the sales in a store at Walmart. Again, a very interesting data science problem. Okay. Very interesting data science problem. More specifically, we call it a regression problem. Now, why do we call it a regression problem? because we are trying to predict a numerical variable. So I think this was a term that we used a while back, regression. What is regression? Regression problems are basically belong to a family of problems where the output that we are trying to predict is a number. We are trying to predict a numerical output, just like that, hey, how many runs will a player score? Okay, so based on all the features of the player, we are trying to predict how many runs they will score or how many points they will score. Or you're trying to predict how much of sales will happen, how much of demand will creep up. What is the temperature going to be tomorrow? What is the stock price going to be by the end of Friday? All these, these stock market investment, bankers will give you recommendations. The current market price is so and so. The target price is so and so after 2 months. These are all regression models. Stock price forecasting. Anything where you're trying to predict a numerical output, including this one, Walmart sales, what I'm demonstrating right now. It's a regression problem. So what do we call it? We call it regression. So based on all the input features, based on all the inputs, you're trying to predict the output. So based on the raw dirty data, you are trying to figure out, you're trying to predict a numerical output, a numerical sales. Now, in a real world project, data will typically come from many, many sources. This is just to give you a rough idea about the whole life cycle, then we'll come to the case study. So just to walk you through this one again, first things first, what we are doing is data discovery. And data discovery is where we try to figure out, we try to frame the business problem. And after framing the business problem, we try to figure out, what type of data we have and what are the different sources of data we have, where we should take our data from. That's what we are trying to solve here. So what are the different sources of data? That's what we are trying to figure out. What type of data sources we should have. That is what we are inherently trying to do in data discovery. Identifying the data sources, define the problem statement. So for something like a Walmart case study, you frame the problem statement. You say that, hey, we want to look at all the historical data. And based on the historical data, we want to predict the sales in a Walmart store for next month, next year, next quarter, and so on and so forth. And after we frame the problem statement, we try to figure out what sources of data we will have. What are the different data sources we will have? So we'll identify key 3, 4, 5, 6, 7, 8 different data sources we will try to figure out. And after we figure out the data sources, we will go back and do data ingestion. Data ingestion is the part where we go back and try to read data from a particular source. So in the case of Walmart sales prediction, what kind of sources are we talking about? What kind of data sources are we talking about in Walmart? So the kind of data sources we are talking about here are, let's say, one could be the historical sales data from the Walmart stores. So if you're trying to predict how much of sales will happen in December, a very important source of information will be how much of sales already happened until November. So all the way until November, how much of sales happened? Then we'll also need to have information about the weather. So we'll also need to have some information about the weather. So just to write it down a little, just to go back and write it down a little, let me just quickly go and write it down. What are the different sources that are important? Let me just quickly take a minute and write it down. Just to help you get a feel for what we are doing. And this is once again getting into the domain side of things, because the domain knowledge part is again very, very important, because to solve this particular problem, you need to have the domain. You need to really know what type of things are actually essential. So the domain knowledge part is once again extremely crucial in this context. Just trying to open up an empty whiteboard here. Just a minute, guys. Okay, here it is. So this is the problem that we are trying to solve. And you identify what type of sources are required to predict the Walmart sales. So one source will be the historical sales data. This will be coming from Walmart's own systems. One more source of data will come from the weather APIs, because this will also be a very important predictor of sales, right? Let's say December is a very important period for companies like Walmart, because they're constantly trying to figure out like, hey, how much of sales will happen in the month of December. Let's say, because December is like Christmas, New Year, a lot of customers will shop. So weather will also be a very important factor, because keeping all the factors constant, given all other factors are constant, if the weather is bad, nobody will come out to shop. Like what happened last year. The shopping trends actually reduced a lot, I would say. So the shopping patterns reduced a lot because there was a bomb cyclone, there were cold weather conditions persisting across the US. So people did not want to go out and shop. So these are all important factors: sales, historical sales, weather API data, macroeconomic data. We will need to access data from macroeconomic sources. And good example of this will be Federal Reserve, interest rates, unemployment rate. Interest rates have increased. Interest rates have increased means lending has increased. Customers have to pay more EMIs and there is less disposable income that they have. Unemployment rate, you will look at. What is the unemployment rate? Right now, we are seeing a lot of job cuts are happening, right? There is a recessionary fear in the economy. So if the unemployment rate is very high, that will also be a very important predictor in helping you predict how much sales will happen. So given all other factors are constant, if the macroeconomic factors are not conducive, then that will have a direct impact on the future sales. So historical sales, weather, macroeconomic data, stock market data. Look at other similar companies in the industry. To look for other similar companies in the industry. Look for your Amazon. Look for your Target. See how they are performing, and based on that, you can try to predict the information. You can try to predict the stock price of. You can try to predict how will Amazon, Walmart perform. And finally, you can also look at competitor analysis, because other similar companies, let's say S&P 500. If the S&P 500 is doing well, that means the economy as a whole is doing well. And you will use that information once again to estimate the sales. So what I'm trying to get at is all of these are basically part of your raw dirty data. So all this while we were talking about data science. So all of this is part of your raw dirty data. So use your domain knowledge, figure out what type of data sources you need to solve the problem, identify those data sources, clean this data, bring them into one common source, join them into one common source data frame or a structured format, and then using that, you try to build your models. And then you use those models to gain insights. And that's the crux of what we are trying to do in a typical data science life cycle. We start off with raw, dirty data, which make no sense, and then you use that data to generate information or insights. The same thing we were doing at Dream11 also, just that we had historical player data, weather data, and you're also looking at information about the venue, information about the matches, information about the players, the pricing, the contracts, the multiple different sources we have. And it's a very complex system that they have, where they're trying to use all the data. They're trying to merge it into one common system, and then they're trying to build a model. So that's the crux of what they're trying to do. And just to kind of show you, there's a wonderful piece of code I wanted to just mention. This is the GitHub repo that I wanted to quickly show you. Again, I think there's a lot we can talk about it. But you can just take a look at this GitHub repo where, I just wanted to quickly show you a little bit of code where there's a wonderful Dream11 predictor thing that is actually built. So they've done something very similar where they've actually taken data from the historical IPL matches. They've taken the historical data. They've actually taken the weather. They've actually taken the information of the other things, and they've tried to build a model. I'm just going to quickly share that across with you. So just in case some of you are interested, you can actually look at this one. And this is not my work. It's basically the work of one of the authors. I wanted to just share that. And if you see the performance of the models, how much of error rate they're getting, what kind of returns they got. And they also actually try to calculate that when these models were used, how much of rewards they got on 2019 test data. And that corresponded to how much of total monetary rewards. We can actually look at that. Very interesting. I think machine learning will never work on one match or two match or three matches. But what really amazes is the power of mathematics when you apply that over several hundreds of matches. I think the rewards basically magnify. So that's the real magic. So I just wanted to quickly share with you. This is the wonderful article where they've actually tried to use some Python code and they try to implement machine learning. Just wanted to share that. Anyways, let's move on. Let's come back. This is the life cycle. Once again, data discovery, read your data, clean your data. Data wrangling is again very, very important, especially when you're reading weather data. Let's say you might come across instances where there are certain dirty value, garbage you have, there's certain incorrect data you have. So a lot of those issues will persist. So how do you go back and take the raw dirty data and how do you clean and pre-process your data. So data wrangling and data cleaning will be a very integral part of the whole analysis. And after that, you will do data exploration or EDA, and then you will start with the model building process. So this is the part where you take your data, clean your data, join your data, and then you start with the entire machine learning model building process where you build models, you try out different models, evaluate the models, compare across multiple models, and then you deploy the final model. So that's one way to look at it overall. Okay, so this is the basic life cycle of a typical data science project. I showed you the Walmart use case here. There is one more very interesting one. There is very interesting one that we also have with respect to American Express. I think I was talking about one use case, and all these competitions are used by real organizations for hiring. So I just wanted to quickly mention that all these are used by real organizations for hiring purpose. And if you look at it, this was a competition by Amex 8 months back, where they actually tried to use the results of the competition. So where they actually tried to use the results of the competition, and on the basis of that, they tried to use the attributes of a customer, and based on that, they try to predict whether the customer will default or not. So this is the interesting problem that American Express hosted almost 8 months back, and we are seeing a lot of this happening in the hiring space today, where the traditional modes of hiring just on the basis of resumes and you give a CV and we look at it, that's actually gone. So we are seeing a lot of these competition platforms like American Express, Walmart. They actually host competitions on platforms like Kaggle and even AlmaBetter as well. We also have a lot of hackathons in our platform as well, where we conduct those hackathons. And based on how you perform, based on how you code, how you perform real time on those competitions, you're actually given prizes and you're shortlisted for certain types of organizations and stuff like that. So you're seeing a lot of new hiring practices also coming up, right? There's also prize money to be won. And if you come all the way down, it says that, hey, it gives you an opportunity to interview with American Express. So this is something that is actually being monitored in a big way, how your algorithms and how your models are performing on real world data. Okay. Because mind you, the data that is shared is real world entirely. I mean, even in our sessions, we actually work with this kind of real data. So we are looking at real world data right now. And if you take a look at it, generally speaking, we are seeing credit card default prediction models. Next month, how do you predict the probability that your card will default? Next month, how do you predict what is the probability that your card will default? So next month, how do you predict what is the probability that your card will default? So Amex is constantly running these kind of default prediction models, and based on the different features of the customer, it is constantly trying to predict what is the probability that the card will default. What is the probability the card will not default? They're trying to constantly build these kind of card prediction models overall. And if the customer is predicted to be a defaulter, then the card is proactively blocked. If the customer is not predicted to be a defaulter, the card is not blocked. Okay, so I repeat, if the customer is predicted to be a defaulter, the card is not blocked. If the customer is not predicted to be a defaulter, the card is blocked. The card is not blocked. Other way around, sorry, small typo. Okay, so these kind of models are actually used. So all of a sudden, let's say you get up in one fine day and you go to the bank and you try to swipe the card. Right? If you see the card is somehow not working, so know that intermediaries like Visa, Mastercard, and American Express, they actually use models behind the scenes to predict what is the probability that you will default. And if your default probability is very high based on your past usage and your credit score and all that, they will practically block your account. That's how it actually works now. And if you think through what kind of data sources Amex is using, because this is also like a prediction problem, and if you try to think through what type of data sources Amex is using, the kind of data sources American Express is using is, let's say, they'll be looking at your credit score data, which they will fetch from multiple agencies. They will look at other tertiary sources. They will look at Amex's own data. Amex will have its own primary data about the customer. How have you used the credit card? How have you made the past monthly payments? So what has your history been with the bank? Have you defaulted any time? So they will look at your past usage data. And based on that, they will try to predict the probability of default. So these are some interesting problems that we are actually solving as part of data science once again. Okay. Now coming to regression, I think as I was discussing, regression belongs to a family of problems where you're trying to predict a number. It can be a player performance prediction, how much runs you will score, how much points you will get, what is the weather. So these are all basically belonging to a family of problems that are called regression. And think of it this way, just write it down. So regression belongs to a family of problems where You are trying to predict a numerical input. Okay, so we are trying to predict a numerical output. I'll give you a very simple, intuitive understanding of what we are doing in regression. Now, there are different algorithms that are actually used to do this thing. But what I will do is I'll give you a very basic, intuitive understanding of regression in the session right now. Let's say we have some X and we have some Y. X is basically the input and Y is the output. And in line with what we try to do in machine learning, the whole thing is what we refer to as machine learning. So what are we trying to do in machine learning? So we are trying to feed the machine lots and lots of these input-output combinations, XY combinations, XY, 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 so on and so forth. So we are trying to feed the model lots and lots of these typical XY combinations. And we are trying to build a model. And next time there is a new X, we are trying to find the predicted value of Y. That's the way we are solving the whole thing. So again, we have, let's say, 1 and 2. We have 3 and 4. We have 4 and 5. And we have 6 and 7. So there goes the input-output combination that we are feeding in. Let's say this is the historical data that you will feed into the system. And next time I say, what is the corresponding output for 7? This is what you're trying to predict. Okay, so 1, 2, 3, 4, 4, 5, 6, 7. So this is the historical data 1, 2, 3, 4, 4, 5, 6, 7. That's the historical input-output combination that you have right now, X5 combination that you have right now. And you will use this data and you will build a model on the basis of this historical data. And next time there is a new input, 7, the model will predict the output will be 8. This is how the crux of everything will basically go on. So we are looking at the historical input-output combinations, 1, 2, 3, 4, 4, 5, 6, 7. This is the historical data that we have. So learn the patterns on the basis of the historical data. We can also try to visually represent the whole thing in a mathematical graph. Let me just plot it out also, just to show you both the aspects and dimensions right now. So we have the origin, which is present somewhere here as the origin. So we have 1, 2. There goes 1, 2. There goes 3, 4. There goes 4, 5. And there goes 6, 7. So there goes the historical input-output data that we have right now. You simply plotted it out right now in the XY plane. And now, on the basis of this available data, on the basis of whatever data that you're feeding in, on the basis of whatever data that you're feeding in, we will use some algorithm. And on the basis of that, we will try to build a mathematical model or a function that relates the X and the Y's. That's the crux of what we are trying to do in the regression model, specifically the machine learning regression model. That is what we are ultimately trying to do. Okay. So we have input-output combinations. We feed the machine with lots and lots of these X, Y data, 1, 2, 3, 4, 4, 5, 6, 7. We use some algorithm. We use some machine learning algorithm. And on the basis of that, we are trying to build a machine learning model. And the machine learning model is what we call the mathematical function. That's what we are trying to build. So what is this? What is the model that we end up building? Can anybody tell me the equation? What is the pattern that we are able to learn on the basis of this historical data? Okay. So based on the X5 combination, what is the pattern we are able to learn? The pattern we are able to learn is Y equal to X plus 1. Exactly. Exactly. That's the mathematical detail Anansha has rightly mentioned. So this is going to be Y equal to X plus 1. So what you're trying to do is you're trying to learn the mathematical model Y equal to X plus 1. So on the basis of the historical data, we're able to see that the line equation or the mathematical model that we're able to learn is Y equal to X plus 1. And now using that, we will do a prediction, and the predicted value for this new X will be equal to 8. So this is the crux of what we are trying to do in a regression problem. So this is a very simple use case I showed you, where based on one X, you're trying to predict a single Y. But in reality, there can be hundreds of input features. So inputs are also called features. I've used the terms interchangeably. So sometimes we can call them inputs or also call them features, or we can call them dimensions. And sometimes we also call them attributes. So there are different jargons that we go back and use in the process. We call them inputs or features or dimensions or attributes. And based on these input features, we are trying to predict the output. So 1, 2, 3, 4, 5, 4, 5, 6, 7. So learn the patterns on the basis of the historical data, use the algorithm and build a mathematical model or a function, which is y equal to x plus 1. And if you want to understand this a little bit more pictorially and visually, if you want to look at this a little bit more pictorially and visually, so this is how the whole thing will look like a little bit more visually right now. All if you can see the screen, how the thing will look like. And so you're trying to find out what is the line that best fits the points. It turns out the line of best fit looks somewhat like this. There goes the line of best fit here. So this is the historical data 1, 2, 3, 4, 4, 5, 6, 7. On the basis of this historical data, use some algorithm, and on the basis of that, you build a model. And the mathematical model equation that we end up getting will be y equal to x plus 1. So there goes the equation of the mathematical model that we're getting right now. So and using that equation, next time there is a new value of x, next time that x is equal to 7, we'll try to predict the value of y. The next time x is equal to 7, what is the predicted value of y? The predicted value of y is equal to 8. That's the crux of what we are trying to do. So next time that x is equal to 7, what is the predicted value of y? The predicted value of y is equal to 8. So this is how we are trying to build a model to learn the patterns. And the next stage is next time there is a new input x. Based on the new input x, we are trying to find out the predicted value of y. So based on x equal to 7, we are trying to find out what is the predicted value of y. That's what we are able to get right now overall. Right? Hope this is absolutely clear. Hope all of you are able to figure out the crux of what we are trying to do in a typical regression problem. And only thing is that this can be extended to more complex problems. Now, what we saw here was a simple x-y relationship that we are trying to learn. Now, something like a Dream11, we are doing something very similar. Let's say based on the historical runs code, you can have a ton of features here, x1, x2, x3, x4. So we'll typically have many inputs of features. So based on, let's say, the runs code historically, based on the temperature, based on the venue, the city where the match is being played, based on the other conditions, we are trying to predict how much of score you will get. This is a much more complex regression model where based on all these input features, x1, x2, x3 up to x50, we are trying to predict the score. So this is a slightly more advanced use case of what we are doing in regression. Okay, that's what we are doing. Now, one question people might have is that, Sayan, is it guaranteed that the data points will all pass through the line? Not really. You can absolutely have a scenario like this. So x-pi combinations can also look somewhat like this. Okay, it can be a stretch data points like this, and you're trying to find the best fit line. So regression is all about finding out what is the line or surface of best fit. Okay, so line or surface of best fit. This is one of the things that we are trying to do typically in a linear regression model. And just to also show you a beautiful analogy, which is just what I wanted to quickly show you. This is the crux of what we are doing. So if you see that we have actually taken a small use case where there's some x we have taken, some y we have taken. This is how we can visualize regression. So I just wanted to show you a very small visualization of regression. You can see how we are aligning the x and y data points along the mathematical surface. This is how the whole thing will actually look like. So we have lots and lots of these x-y combinations, and we can see that there is hand size, there is height. So we're looking at lots and lots of these so-called x-y combinations right now. And based on this, we are trying to find out what is the line that best fits the points. So we have lots and lots of these, again, so-called x-y combinations, xy, 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 and so on and so forth. And we are trying to find out on the basis of this x-y combinations, we are trying to find out what is the line or plane or mathematical surface that best fits the points. We are trying to find out the best fit. What is the line of best fit is what we are trying to find out. Okay, so best fit is what we are trying to find out. And once we are able to find that best fit, next time there is a new value of x, we can find out the predicted value of y. Okay, so next time there is a new x, we can find out what is the predicted value of y. That's how we can go back into the whole thing. Okay, wonderful. Now, you might be wondering, is it only relevant in the context of one x? Not really. Just that it becomes difficult to visualize for multiple features. So whatever we are seeing with respect to a single feature, it becomes a little difficult to visualize with respect to multiple features. But absolutely, yes, you can do this with respect to multiple features also. So whatever we are seeing right now, you can absolutely go back and look at it and visualize this in the context of multiple features also. Okay, wonderful. So just wanted to quickly take you through the regression problem. Hope all of you understand this now a little better. Now, mathematically, this is a little difficult, and that is something we will not get into too much of detail. But I hope the basic technical understanding is clear as to what we are doing in the context of Dream11, what we are doing in the context of taking in the historical data, how we are able to use all these input features, and how we are actually designing a player prediction kind of a model. I hope all of you are able to get a basic flow framework. And this is the crux of what we talked about, how the predictive ML algorithms are actually working. Pretty much what we talked about in the simple regression example as well as we spoke right now, where you can see at the top, we have the historical data. We use some algorithm and we build a model. This is the part where we take in the X, Y combinations and we were able to use some algorithm and we built a model. The model was Y equal to X plus 1. That was the example that we saw. And next time there is a new data. Next time there is a new value of X. We can use that same X plus 1 function to predict 8, Y equal to 8. Now, in case you're wondering what type of algorithms that we have, okay, so what type of algorithms do Dream11 use for building the regression models for player prediction? Well, these are the kind of algorithms that Dream11 is actually using. Not linear regression, it's an example, but then typically boosting random forests and neural networks are very, very popular, and these are some of the favorite models that organizations like Dream11 is actually using. Specifically for regression that we just now talked about. So these are the kind of algorithms that are being used to find out that y equal to x plus 1 equation. So how is it able to figure out based on the historical data? How is it able to learn that y is x plus 1? So these are the algorithms that are actually used, and that's the technical details behind how these things are being implemented. Okay, and then the next thing that we do is we evaluate. Like we try out different algorithms, we try out different models, and then we evaluate the models with respect to different metrics, different accuracy metrics, like how accurate the model is. And these are the different accuracy metrics that Dream11 uses to evaluate the models, right? So this is just to give you a bit of a flow idea with respect to what we are doing in machine learning, what we are doing in regression, and also, as you can see, how we are going about the whole thing, like what type of algorithms that we have. So all of you do keep in mind you, there's a quiz also that we have actually in a while from now. So please do remember, all of you. We'll see how many of you are able to remember these things. Yeah. So these are some of the algorithms that we actually have: linear regression, decision tree, random forest, gradient boosting, and neural networks. And these algorithms are actually used to learn the patterns explicitly, right? All right. Now, I think we talked about NLP a little briefly already. So this is again a fascinating use case that we have. I think we talked about the haptic AI, conversational AI chatbot. A lot is being talked about nowadays with respect to Chat GPT. I think we have got an innumerable number of use cases where Chat GPT is used for lots of use cases. So we will probably have a session later on Chat GPT exclusively. So, but then just to give you a little bit of basic understanding of natural language processing. So anything that has to do with understanding and processing the natural language, and that can be in any language. It can be English, Hindi, whatever the language that you're looking at. Anything that deals with processing and interpreting the language belongs to this entire domain of NLP. And there are lots of interesting problems that we are solving. So as I told you, Dream11, specifically Dream11 is using NLP techniques to analyze user feedback and comments data. This is what they're using to improve customer support, using user engagement. All this we are doing. But there are lots of other incredible use cases where these kind of things are actually used. So if you just have to talk a little bit about some of the other applications of natural language processing, because there are tons of it. There are tons of applications that we have with respect to NLP also. So just to give you a little bit of sense as to what are the other avenues and what are the other scenarios where NLP will be actually useful. So these are some of the classic applications I wanted to talk about very, very quickly with all of you. I think you can already start to see emails are a fascinating use case. We can look at email data, and we can understand based on the email data, we can try to do spam classification. So next time we have an email, we can use machine learning models to predict whether the mail is a spam or a ham. So these kind of models can be built. Emails also have this feature where you can automatically look at an email and you can figure out what kind of topics are being talked about. Okay, so you can go back and talk about what kind of topics are being talked about. Google Gmail also categorizes mails into different buckets like important, social, promotions, and all that. So even that is an excellent prediction problem. So next time you have an email, based on the contents of the email, I'm able to automatically classify which category the email belongs to. Is it category of social? Is it category promotions and all that? So this is again an excellent use case what you're doing. A more advanced case with respect to emails will be auto response, where next time you get an email, Gmail will automatically draft a response for you. Like, hey, let's say somebody sends a message saying, happy birthday. Gmail will automatically send out a response saying, okay, thank you. So these kind of use cases are also there. So based on certain types of emails, Gmail will send out automatic responses to you as well. Okay, social media updates are also a great use case. Chat interactions, even WhatsApp has auto response mechanisms. You can go to the notifications pane, and when you get a message, WhatsApp will trigger auto responses. Let's say, okay, thank you, and all that. So even Outlook has some interesting responses, interesting AI responses around emails as well. Even Outlook does it in a big way, where I would say, based on the contents of the email, Outlook will often try to predict, like based on the contents of the email, Outlook will try to predict or give you an auto response. Let's say you get a message saying that, hey, let's meet up, let's catch up over a meeting at tomorrow for 5 p.m. If you get an email like that, Outlook will automatically schedule a calendar invite. It will automatically recommend a calendar invite for you. So these kind of things are already built into Outlook. So let's say I send one of you an email saying, hey, let's catch up over a call tomorrow to discuss some doubts about what we are discussing today. Let's schedule a call tomorrow at 5 p.m. So Outlook will automatically create a calendar meeting for me at 5 p.m. Outlook will say, hey, Sayan, do you want to create a calendar invite tomorrow? So these kind of incredible features are also there. So these are some examples of language data where natural language processing or NLP techniques are actually applied. Talking about social media, one more great use case will be sentiment analysis. If you talk about the kind of stuff people post on Facebook, people post on Twitter, people are, let's say there's a brand promotion that happens and somebody, people have posted comments about how they like the product, something of that sort. So we can do sentiment analysis. An organization can do a sentiment analysis on the entire set of comments, and they can try to understand how people are talking about that particular product. Okay. So how are people talking about that particular product? So these kind of problems can be once again solved. So is the overall sentiment for the product positive? Is the overall sentiment for the product negative? So all these interesting problems can be once again solved. The sentiment analysis. Google phone keyboard, mobile phone keyboard, you start typing something, auto completion. Google also is a good use case where you start typing something, the auto completion, the words basically get predicted. So these are excellent NLP based solutions we have. Conversational AI chatbots, we talked about it, Alexa, Siri. In fact, haptic also that Dream11 uses are excellent use cases. Not like those static chatbots. I'm not talking about the typical static chatbots where there are predefined responses. I think a great example of a static chatbot will be iMobile. If I just take you to, that's actually a useless chatbot. I will not even call it a chatbot. That's actually a useless chatbot. Sorry, not iMobile. Sorry, this is your. Sorry, my mistake. This is your Ask iPal. I'll quickly go to ICICI Bank website, and potentially Ask iPal will pick up. Look at this one. So almost all websites nowadays are virtual assistants. This is a good use case of what a typical static virtual assistant will look like. Not conversational AI, but a static virtual assistant. You can see, you can start asking questions. You can ask questions about a range of topics. You can say send money and it will give you some answers and stuff like that. But if I ask you something like, what is the best credit card? If I ask some more intuitive conversational queries, it'll not give me the right answers, because I'm expecting ICICI Bank to tell me that, hey, I'm in the bank right now. You tell me what is the best credit card you have to offer, and it doesn't even understand what I'm asking. It says, okay, go to the credit card section, and it'll do a pretty. So these are basically pre-saved responses. This is the keyword-based search it is doing based on whatever keywords I'm entering. It is simply giving me options based on that, but it is not like a virtual assistant that we are expecting. It's like a very basic static chatbot, not a dynamic conversational AI chatbot like what Haptic uses and what Dream11 also uses basically. The Google Assistant will never do this. Google Assistant will always give you an answer to the question. If you ask what is the best credit card, Google will always give you a list of links which tell you what the best cards are. ICICI Bank, the best card that they have is Emerald. If you have, they used to give Diamond years back. I think 5-6 years back they used to give Diamond card, but that stopped now. So the top end card by ICC Bank is Emerald, EMERALD. That's above Rubik, Sapphire, and then they give Emerald to premium customers. But it's very static right now. If I just click on credit card, it doesn't even show me the things correctly. See, upgrade card, disable transaction. These are all static rule-based searches what you're having. And if I ask what is the weather, it will probably start complaining, right? It will not even understand the query. So it will only work on the basis of keywords, and whatever keywords I had here didn't make any sense. But a conversational chatbot will never do this. You try doing this for Google Assistant, it will never say they didn't understand the query. It will go back and answer it perfectly. Just wanted to clarify that not all AI solutions are perfect. Many AI solutions that we see nowadays are just static rule-based coding. It's nothing but a simple set of if else statements that we have, like if this, then do this, if this, then do this. There's no real learning happening. And that is different from the use cases we are talking about in conversational AI. Conversational AI is advanced. They will remember what you answered before. They will remember the way you typically like to talk, and they will adjust the responses accordingly. Like Google Assistant, it will remember Google phone, the Gboard. If people use Gboard, if people use Google Assistant remembers the way you pronounce certain things. Gboard will remember certain types of things you tend to type, and it will tend to recommend you those things over time. Okay. Another great use case we have in NLP is text summarization. Great use case, I would say, where you have a very long, lengthy document. And one of the things that we try to do is we try to summarize the whole document. That's another great use case. There can be some wonderful use cases with respect to ebook summaries, book summaries, big legal terms and conditions sheets we have, and how do we use a mathematical machine learning model to summarize that entire sheet with respect to a small summary. We can do all those kind of things. This is also a classic use case of NLP. This lies right at the intersection of computer vision and NLP. Classic use case. I think this is one of the avenues where Dream11 is. I think there's a lot of scope actually, where the entire concept of live commentary, something that Geo is doing in a big way. I think you've heard of it in a big way. Even Geo is doing a lot of things in engaging people in sports. So a lot of those interesting cases are actually in the works. So where they are trying to use computer vision, I think with Geo 5G, True 5G is a wonderful use case. I was reading an article where they're encouraging people to use True 5G and Geo Cinema, how you're able to see matches live real time, and how you can see from different camera angles, and even this kind of thing where you're able to kind of look at a picture or look at an entire video sequence, and the commentary is automatically generated. I know it's very far-fetched, but we still have a lot of use cases for this. Okay, where based on the picture you're seeing, we're able to generate some text. And this is what we refer to as image captioning, where based on the way the player is playing or how the player is playing the shots, it will automatically generate a commentary real time in the video. The commentary will be coming, but obviously it's very far-fetched because these kind of things will be highly prone to mistakes or highly prone to errors. That's one way to look at this one. That's again something that we have to understand. But yeah, it's good to talk about these things, because I think we
Sorry, I just lost you for a minute. I just connected back once again. Yeah, sorry. I know. Just audible back again. Yes, sorry. Just reconnected back my microphone. I was on a headset all this while. So another wonderful use case where this comes in handy is in the space of, I would say, this comes in extremely handy in the space of assisting blind people to see the world. If somebody is not able to see anything, how do you make that person wear some goggles, and how they're able to see what is in front of it, and based on that they're able to the app is able to convert that particular image into text, and then text to speech. This is a great use case again, where you're able to do image to text and then do a text to speech. So image to text, text to speech is once again a wonderful use case of what we are able to see right now overall. Okay. In fact, there's an application called Seeing AI. I think related to what we are discussing right now, there is a particular application called Seeing AI. Let me just quickly share that with all of you. There's a particular application called Seeing AI. Deepak, Deepak will come to that. I think What is the team? You can probably try out the GitHub code. We'll come to that. We'll do an interaction there as well. Hold on. I'm just going to quickly complete the technical conversation. Then we'll come to that. Acha. Maybe we can have a discussion of the team at the end of the class. We'll come to that. Hold on. So okay. So Seeing AI is a wonderful application by Microsoft. This is something that I will really encourage people to do. So just go up and look up something called Seeing AI. And Seeing AI has a particular feature called scene recognition. It's an experimental feature that is used to describe the scene around you. Okay, so it's an experimental feature that is basically used to describe the scene around you. It's an experimental feature that we basically have. So how do we use Seeing AI to experimental feature to describe the scene around you? So you basically point your smartphone camera at the surroundings, and it will describe the surroundings for you. It will basically use text to describe the entire surroundings for you. So that is how the scene recognition feature actually works out. So once again, a great application which can be potentially used by blind people, where they point their camera at the surroundings, and you're able to take that entire image and you're able to convert that to text, and then you're able to take that entire text and you're able to convert that entire text to speech. So that's how the whole thing is actually working out. Okay, wonderful. These are some good use cases I wanted to talk about. I think language translation and all are very common cases. Suggested answers we already talked about. So great use cases in NLP that we have. Another, I think if I have to talk about a couple of other applications, one more application, Truecaller. Maybe let me engage the audience a little. Can somebody tell me some AI ML use cases, NLP use cases for Truecaller? And again, the reason I'm talking about NLP right now is because of the specific application area where it is using Dream11 also. So where do you see Truecaller using natural language processing? Anybody? Truecaller is something I'm sure people have used. It's a caller ID identification app. Where do you see Truecaller using natural language processing and AI to do anything for that matter? What are some of the use cases? Let me hear from the audience. Let me hear a couple of thoughts. Who will answer? Is it spam or not? Very good, Anansha. Very similar to email spam detection. Truecaller also does spam identification. Very good. Very good. Spam. What else? Spam is a known case. Yes. Blocking numbers. Yes, to some extent, it identifies whether the number is a spam or not. And based on that, it will try to block the numbers which are more likely to be spams. Correct. What else? What else are use cases? Yes. What else? So we have spam identification. We have number blocking is a great use case. What else? Identify names of unknown numbers. Not so much. That will, to some amount of machine learning is used. Not So maybe it will look at how people have gone and saved that number in multiple places, and based on that, it will try to predict maybe this is that person. So that's what it does. Yes, that's true to some extent. Yes. Very good. Is it a personal or business number? Exactly. So this is again a feedback that you actually enter when you save the number you enter. Is it personal or business? And based on that, it will try to predict. Next time you get a call, it will say it's a personal call or a business call. Nowadays, Truecaller even is more advanced. If you get calls from certain delivery places like Swiggy or Amazon or something, they even have this feature where they try to, tell you in advance that this is the call that you're actually getting. And very interesting, Truecaller is also coming up with this incredible thing. Let me just quickly show you the blog of Truecaller, because these are all day-to-day things that we are all working with. They have this incredible thing called Truecaller Assistant. So this is, again, this is probably going to be an incredibly powerful thing. I'm still trying to figure out, some of the use cases around it. It's very, very interesting. And then people can try it out. So there's something called Truecaller Assistant, where you can basically make Truecaller accept calls for you. It's powerful AI call screening for iOS and Android. You can see. So you can see they get a new Truecaller Assistant who screens and answers your calls for you. Very interesting. It's almost like that video by Sundar Pichai. People remember that video, huh? Yeah. Did you all remember that video? Let me just show you the haircut video. Sundar Pichai interacts with somebody on a haircut. You all remember that, huh? Let me quickly play that video for you, just in case some of you might have forgotten. So, there's so interlinked topics. One topic takes us to something and all that. So very, very interesting. There was a keynote address at Google where Sundar Pichai basically talks about a Google DoPlay. Google DoPlay is also a natural language assistant, NLP based assistant. And he basically used Google DoPlay to simulate and schedule a call and schedule a haircut. And Google DoPlay was able to automatically interact in this thing. Okay. Just in case people never heard of this, let me just quickly share with you. let me see. I think I need to share the computer sound as well. Okay, here it goes. All of you can see the screen now. Yeah, it's very interesting. Huh? So let me quickly just have my computer audio on, and we can see. Look at this one. This is really incredible. Let me just play it for all of you here.
As I said earlier, our vision for our assistant is to help you get things done. It turns out a big part of getting things done is making a phone call. You may want to get an oil change schedule, maybe call a plumber in the middle of the week, or even schedule a haircut appointment. You know, we are working hard to help users through those moments. We want to connect users to businesses in a good way. Businesses actually rely a lot on this, but even in the US, 60% of small businesses don't have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have at 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
That was a real call you just heard. The amazing thing is the assistant can actually understand the nuances of conversation. We've been working on this technology for many years. It's called Google Duplex. It brings together all our investments over the years in natural language understanding, deep learning, text-to-speech. By the way, when we are done, the assistant can give you a confirmation notification saying your appointment has been taken care of. Let me give you another example. Let's say you want to call a restaurant, but maybe it's a small restaurant which is not easily available to book online. The call actually goes a bit differently than expected. So take a listen.
See how may I hear you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people? When? Today?
Next
Tonight?
Wednesday at 6 p.m.
Oh, actually we leave here for like after 5 people. For 4 people you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Yep. Bye bye.
You can already start to see very interesting. So basically, this is an incredible use case with respect to how natural language processing and conversational AI can basically weave magic. Something very something very similar to what Truecaller Assistant is trying to, something that we use in our day-to-day lives. And you can already start to see how customer support overall can be revolutionized if these things are happening properly. Next time we are facing a service request, we don't have to go and type out in Swiggy or let's say in Dream11 that, hey, my points are not credited or something of that sort. You can directly pick up the phone. You can talk to a customer service agent, just like IVR. We will not have IVRs anymore, but we'll directly pick up the phone. We'll do a call, and based on what we talk, the assistant will automatically understand what we are saying. Just like Google Assistant, Google Do Play product that we saw, assistant will automatically answer questions on the basis of how we talk. So this is again very far-fetched, but these are all realities that we can look at. Okay, it's actually very interesting. Assistant is something you can definitely try out. This is very, very interesting. Truecaller Assistant, you can see we get these numbers and then you can just swipe to answer. And the Truecaller Assistant will basically pick up. You can see, hi, I'm Daniel's assistant. May I ask for the reason of the call? And then the person will say it's an Amazon delivery waiting outside. So the person will basically do the entire screening for you. This is really cool. And then this is how the assistant is actually kind of working. So you can all give it a read right now and just explore some incredible features where machine learning is used in the space of NLP. And the reason I talked about this topic is specifically with respect to NLP and some of the things that even Dream11 is kind of incorporating in their products as we speak. Apart from just a basic sentiment analysis and responding to customer queries, the whole avenue of conversational AI can be completely revolutionized using these kind of use cases. Okay, wonderful. Now, finally, the last part of what I will talk about is basically recommendation. I think we have talked quite a bit about the other use cases generally, so to give you a solid understanding of the topics. And now what we'll see is specifically the recommendation system aspect of Dream11, where they use collaborative filtering algorithms to recommend different players to different users. Because as I told you right up front today, like for the 7:30 match that's going to be played out, how do you recommend the top players? How do you know that which players and which team you will pick up? So how is this specific thing actually done? So Dream11, what they do is there are multiple different approaches that are used for recommendation systems. So recommendation can be on the basis of the players. Recommendation can be on the basis of like the price of the player. So there are multiple factors that will be considered vis-a-vis the recommendation. And based on the different factors, the users will be recommended different items. So you can see that there are two terms that we are using, users and items. And in the case of Dream11, you're recommending players to users. Because users are the customers, and here you're recommending players to users. Now, recommendation can happen in a lot of different ways. The entire field of recommendation system can happen in many different phases. We can go back and recommend movies. If you talk about Netflix, there are two key entities in a typical recommendation system that we typically have. So on one hand, we have users. On the other hand, we have items. These are the two key entities that we have right now. So I repeat again, we have users on one hand, and we have items on the other hand. These are the two key entities we have. So users like this will be recommended items like this. Users like this will be recommended items like this. And next time there is a new user, I will recommend you items like this. Now in this entire conversation, what are these users and items? Let's see. Advertising is a huge space where recommendation is being applied. So how do you recommend different ads to different people? So the entire space where Google is recommending ads for you. Like if you remember, I opened up YouTube in front of you, and YouTube straight away showed me this Sayan Botanica ad, right? I hope you saw that. There was a Sayan Botanica ad I actually saw. And if I quickly go and look at my, if I quickly go and look at this thing, so I was actually shown a Sayan Botanica ad. If you see, I was just browsing for some of these, some of these healthcare products, some of these consumer products a while back, and automatically recommended this particular thing, right? So that's how the ad recommendations actually happen. They will look at your historical data. They will look at what kind of things you're browsing, and based on that, it will recommend you the ads. Movies, we have use cases like Netflix, Amazon Prime, all the OTT platforms in our country, even JioFiber, you talk about Hotstar, Sony Live. All of these are excellent use cases of recommendations, right? You're recommending content to users. The users, there's items, and you're recommending different items to different users. Now the methods and technicalities are different, but this is the entire space of recommendations. Like Spotify is also recommending tracks. Google News, it recommends articles to you, personalized. So different people will see different things based on their past reading habits. And this is completely machine learning. It's completely a prediction problem, just like what we talked about. So based on the historical data, you are trying to predict what they might like. So based on the historical viewing patterns, based on the historical listening patterns, you are trying to predict what they might watch next or what they might hear next in terms of songs in Spotify, right? Social networking sites are also a great use case for recommendations. Even Zomato, Swiggy are good use cases based on your historical data. Swiggy will see what kind of restaurants you visited in the past. And based on that, they will recommend, hey, this is the place you might want to try. We see that, I think right now there's the great restaurant festival going on. Swiggy will say, hey, you visited these last 7-8 restaurants. You typically like to have continental food. We have this new restaurant where they're offering excellent continental food. And we have just onboarded them in the platform. Great review, great discount we're getting. You might want to try it out. So there's a huge space of recommendation happening in the platforms like Swiggy, Zomato, apart from the typical big baskets, Amazon, e-commerce, massive amount of recommendation happening there. Social networking, Facebook, LinkedIn, if you see, again, are great use cases. So people you may know, people you may want to connect to, again, great recommendation use cases we have. Jobs, even LinkedIn jobs, if you see, are a wonderful use case for recommendation, where LinkedIn will recommend different jobs based on your profile, based on the keywords, based on your connections. LinkedIn will recommend different jobs for you, right? All right. So just wanted to give you a little sense with respect to what we are doing in recommendation. There can be different types of recommendation engines that we can build. And just to give you a little bit of basic idea as to what the different types of recommendation engines are, the most basic type of recommendation engine that we have is what we call a popularity-based recommendation system. I think this is the most basic one. This is the kind of thing that actually happens once you are in the platform. Okay, so just to clarify, so the popularity-based recommendation system is basically what happens once you're in the platform, and you try to. So the popularity-based recommendation is something that happens once you are basically in the platform. So let's say you open up YouTube and you don't sign into YouTube. So what kind of recommendation are we doing here in a platform like YouTube? We are actually doing a popularity-based recommendation. I repeat again, where you're basically signing into the platform, and but you're not signing in. So right on day one, right on the very first day, what kind of content do I show you? So even if you're not signed into the website, so I repeat again, even if you're not signed into the website, what kind of content do I still show you? So that's the whole idea behind what we are trying to do in popularity-based recommendations. So YouTube will still have to show you things. YouTube will still have to show you some content on the basis of your past historical data. So that's what we typically refer to as popularity-based. So they will look at your past patterns, they will look at your past browsing data, they will look at what kind of content you are browsing, and based on that, they will recommend you the most popular news articles, the most popular videos, the most popular movies, and so on. Correct. Even the country that you're based on will matter in the whole thing. And the best way to try it out is to completely sign out of YouTube, open an incognito window, and you can see that YouTube will still give you recommendations. This is the easiest to implement. There's no real algorithm or learning that is happening using popularity-based models. So they're simply using this one. So I think in the case of Dream11, a good use case of popularity-based recommendation would be, let's say you're recommending the most popular players. So not that they are personalizing based on your taste or your interests. So based on what people are mostly picking, they're averaging it out and saying, hey, these are the most popular players who are likely to succeed today based on how they have historically performed. So popularity-based is like you're opening an account on Dream11 today. The Dream11 knows nothing about you. See, the moment you have interacted with the platform for some time, it becomes collaborative. Collaborative is something where you're looking at your past data and we are trying to give you more personalized recommendation, like what YouTube does. Based on your past viewing history, they will try to recommend similar videos for you. That's collaborative. Collaborative means you're most personalized. But in popularity based, if you open your account today, Dream11 knows nothing about you. How will they recommend players for today's 7:30 match? So they will look at the most popular players. And based on that, you pick a choice. These are the most popular players. Now you pick a team of 11 based on that. They will not worry about how you typically tend to pick players. Because you might have a very, very, very interesting way you pick players. You might want to pick new players, young players and all that. But Dream11 will straight away show you a popularity list. And now you pick on the basis of that. It will learn based on that. That's popularity based. Another very popular kind of recommendation that we have is something called content-based recommendation. So content-based recommendation is basically based on the content of the items. And a very interesting thing I would wanted to show you, I think Amazon is a great platform where I can demonstrate this for you. Just 2 minutes and then we can take up a use case in Dream11. I'll just pick up this for another 5 minutes or so. Then we'll get into some more interesting conversations. So Amazon is a great platform. We can see this one in. So this is Amazon. So all of you can see this one. So there goes Amazon. And we can basically, let's say we can search for some phones, let's say Samsung S21 FE 5G, something of this sort we are searching. Or we can go and search for Samsung S20 FE 5G. So what you are seeing here right now, come all the way down, compare with similar items. This is actually an example of content-based recommendation. So this is the phone that you're browsing right now. And based on this phone, you're able to see similar phones. So these are all similar phones that you're seeing based on the different attributes. So based on the screen size, screen type, battery power, RAM, camera, megapixel, and all that. So phones of this type are very similar to phones of this type. Similar based on what? Similar based on content, similar based on attributes. So the features of all these phones are very similar. So if the phone that we are browsing has this much RAM, this much battery capacity and all that, these phones are also very, very similar in terms of the content. Similar RAM, similar battery capacity, inches, screen size, screen type, description, all that. So these are all very similar phones we have. This phone and this phone are very similar in terms of the attributes. So content based. So next time I'm browsing this phone, Amazon will recommend these phones to me. Why? Because they are similar in terms of the content. See, if I'm basically looking at somebody like Andre Russell, the model will recommend somebody like a Kyron Poddar. The model will recommend somebody like a Hardik Pandya, or the model will recommend somebody, the big six-hitters, like you name some other six-hitters, big six-hitters, like, So that's the idea. You're looking at the different attributes of the player. Maybe if I'm looking for, the content will be the different attributes. Batting average, strike rate, number of sixes, number of boundaries. IPL is more about boundaries, right? So sixes, fours are not differentiated. You look at boundaries. So we want to pick players based on number of boundaries. So if I'm picking up somebody like Andre Russell, the model will recommend other similar players, similar to Russell. Similar to Russell in terms of sixes, similar to Russell in terms of boundaries, in terms of strike rate. That's it. Not batting average. Batting average, nobody cares. Strike rate, what matters? Yes, to some extent, average, basic average you need to have, but that's right. That's content based. So popularity based, right on day one, what you see on the screen. Here goes the most popular player Dream11 will recommend. Content based, if I select a player, Dream11 will tell me that, hey, you selected this player. These are all similar players you have. So do you want to line up with only six-hitters, with only high strike rate players, something of that sort? So back in his good old days, if I talk about cricket 4 or 5 years back, see, I'm very biased about cricket. I'll be very honest. I think the cricket we had, let's say, 10 years back is no longer today. I'm still extremely, extremely fascinated by that era of IPL, 2008. That was the, around that time, that was the very first edition of IPL. That period, if you talk about, and we had players like, Adam Gilchrist, Sanat Jayasuriya. We had Sachin Tendulkar. I still remember the Mumbai Indians, the opening pair was Tendulkar and Jayasuriya. I don't think we can ever have this kind of a thing before. And if you remember, there was there was, I think if I remember it right, Chennai, I think they were, I forgot the name, sorry. This was, I think it's most likely Chennai Super Kings. They had an opening pair of Adam Gilchrist and Matthew Hidden. Adam Gilchrist and Matthew Hidden, there's Simons coming, and I think there's 4 or 5 Simons was coming. So there's that was the golden era of cricket, I would probably say. So in that kind of a scenario, if I go and pick up somebody like, let's say if I'm choosing somebody like an Andrew Simons, if I say the most similar players will be based on content-based filtering, the most similar players will be somebody like a Kyron Pollard, an Andre Russell, an MS Dhoni, and Yuvraj Singh. They were all 6-hitters, right? They were all big hitters of the ball. And if I'm talking about international players, we probably have like Shahid Afridi. Afridi was also quite feared for 6-hitting. Back in his good old days, Afridi was a very good batsman, but not anymore, obviously. So these were some good use cases we have. This is what we call content-based filtering. And in Amazon platform, what is collaborative filtering? Collaborative filtering is basically this one. Customers who buy this also buy this. Okay. So customers who view this item also view this item. This is what collaborative is. So popularity, just based on popularity. Content based is just on the basis of the features of the product. And collaborative is basically customers like you. The Sayan, we know your viewing patterns. We know what kind of things you like to view. We know your patterns of viewing. We know what kind of players you like to select in Dream11. So based on the kind of players that you typically like to select, these are some things I think you might like. That's how collaborative filtering basically works out. And this is pretty much what collaborative filtering basically is in the context of what we are doing in Dream11 here. Right? So just wanted to give you the term what collaborative filtering looks at. So it uses collaborative filtering to recommend players to users based on their past team selections
mind you, historical data, not for new users, historical data, and team selections of other users with similar preferences. If I'm a user and if we have one of you in the audience and we are very similar in terms of our tastes, and let's say you selected a player, Dream11 will also recommend the same player to you. It's anonymous data. Obviously, it will not tell you that, hey, this user is very similar, but it will look at users' tastes. If me and you are very similar in terms of the teams we select, Dream11 will classify us as similar users. It will say, hey, Sayan, you are very similar to person A. So person A has selected this player. So Sayan, why don't you select this player? So people like you have selected these players. So you might want to give it a try also. Your tastes are very similar. So you might want to give it a try. See this player. It might be a very unknown player actually. There's one more kind of recommendation system that we have, which is, I just want to give you the term here. It's called association analysis or a priori. If you look at it, it's actually called association analysis or a priori model. There's one more kind of recommendation system that we have. I'm not sure if it came up here. Let me just see. I think it didn't come up here. Yes, it came up here actually. Look at this one. Frequently bought together. So we actually looked at a real-time Amazon use case today. We looked at content-based, we looked at collaborative, we looked at popularity-based, and now we are looking at something called association rule mining based, frequently bought together. So customers who typically buy this S20 FE phone also buy this particular screen guard. Edge to edge, what is that? Tempered glass. I think tempered glass, tempered glass is what they have. So these two products are bought together. Okay, this is what we call association rule mining. So customers who buy this also buy this. So customers who purchase this phone also bought this phone. So all that they are doing is they are looking at hundreds and thousands of transactional data that is playing out. And they're saying that customers who pick this also pick this. Users who pick this player also pick this player. Next time I pick a particular player, the model will say, hey, Sayan, people who pick this player in the team also pick this player in the team. You might want to pick both together. Association rule mining. Happens a lot in platforms like 1mg. If I have to give you a slightly different use case, I've been talking quite a bit about Amazon all this while. So I just have to talk about a very, very popular platform called 1mg. It's a health tech platform where you can order medicines. Even PharmEasy is also a good example we have, right? So if I just quickly search for LIMSI, you will see a classic use case here as well. People who buy this also buy this. LIMSI and Zandu aloe vera juice are typically bought together. Maybe customers like healthcare products here. So people who buy this also buy this, frequently bought together. Association rule mining. And if you come all the way down, content-based, similar products based on the medical composition. LIMSI is a vitamin C tablet. LIMSI is very similar to, I think we have Vaseline, very similar. The vitamin C tablets, vitamin C content is 500 mg. They're very similar tablets. Citravite is also very similar. 500 mg of this is present. Sodium ascorbate, I think, yes. And if you come all the way down, customers who bought this also bought this. Collaborative. So we saw content-based, we saw collaborative filtering, we saw association rule mining. Okay, and this is very similar to what we are doing in this case. Very interesting case. Walmart case study dating back 20 years back, where Walmart found that customers who bought beer also bought diaper. Market basket analysis. Typically the kind of stuff that is stuff of legends in retail stores, where typically in retail stores, how are items stocked? How are items typically stocked in retail stores? How do organizations stock items in retail stores? So they use this kind of a system. So customers who buy product A also buy product B. So customers who buy this also buy this. Customers who buy a certain product also buy a certain product. And that's how typically items are stocked in retail stores. Next time you look at a soap being stocked somewhere, how do you know a shampoo will also be coming? Typically, brands will package a shampoo along with it because you know from the historical data that people who buy a soap also buy a shampoo. This from the historical transactional data, you're able to see that people who buy soap also buy shampoo. You're able to see that it's part of your historical data. People who buy soap also buy shampoo. So people who buy beer also buy diaper. That's the way we're able to look at the whole thing. Okay, and this is what we call association rule mining once again. Okay, this is the whole idea behind what we are doing in association rule mining. Okay, another very interesting use case. Again, a Walmart case study where they found that there's a very strong relationship between hurricanes and strawberry Pop-Tarts. So whenever hurricanes are about to strike, strawberry Pop-Tart sales are increasing. So there's a very strong relationship that we have between hurricanes and strawberry Pop-Tarts. Whenever hurricanes are about to strike, strawberry Pop-Tarts sales tend to increase. We're able to see that overall. Okay, all right. Now we're able to see this one in action.
all of you are able to see, this is what we refer to as association rule mining based analysis. Just wanted to give you a little bit of brief in terms of what type of different recommendation systems we have. I think we've talked about this in a lot of detail. So there are some fascinating use cases we have in AI ML, and what we wanted to do in today's session is not only talk about Dream11, what the organization is about, what fantasy gaming is about, but we also wanted to give you some technical know-how with respect to how Dream11 is solving a regression problem to predict player performance. What is regression? What are we doing? What is the mathematical ML model? What is the best fit line? And then we also looked at some use cases with respect to NLP, how Dream11 is using natural language processing in the form of haptic AI, conversational AI, and what are use cases there. And finally, the recommendation part is what we looked at. So there are 3 broad problem statements we have, but then we were able to see some interesting cases where we were able to kind of some interesting cases we were able to see across a wide range of different domains also we saw, right? So that's the other part of what we were looking at. We'll come to a small Kahoot quiz as well. So this is the part where we come right towards the fag end of the sessions, and we still have quite a few things to talk about here. So before I get going, let me quickly share across a few things with all of you. And I want to very quickly just also share with you one more very interesting piece of information. There's some of you who might be interested to know how Dream11 uses the AI stack. I think we talked about it very extensively in the session overall. What's the? Okay, sure. Yeah. So I'm just going to quickly share this with you for people in the audience who will be who will probably be interested to know a little bit about the tech stack. So the tech stack is very interesting. This is something that you can read a little bit about. I will not get too much into the technical details of it right now, but just for people who are interested to know what is the typical tool stack that Dream11 uses, this is pretty much what we have here. And out of which I think the team will also talk about some of the programs at AlmaBetter that we have, and you will typically see that ML Flow, ML Ops, these are some of the things we teach you in detail. We teach you SQL in detail. We teach you Python in detail. TensorFlow is something we teach you in detail. So there are a lot of aspects that you see in Dream11 that we actually cover extensively in the programs with real case studies. Just wanted to quickly make you aware a little bit about this particular tech stack here. Yeah, just wanted to quickly mention that. Yeah. Okay, now time for the Kahoot quiz. This is something that I will quickly run for the audience right now. So just give me a minute while I launch the quiz. The whole objective is to kind of see how far you're able to remember the topics that we taught you, how far engaged you are in the session, and there are lots of prizes to be won. We have the team that is also going to monitor you in the quiz. We have a huge audience here, and we're going to have a Kahoot quiz here and see how you perform. So just give me a second while I quickly launch the Kahoot quiz here. Just give me a second here, guys. So I'll quickly share with you the link to the Kahoot quiz here. All of you can see the screen right now. So this is basically the game pin that you have right now. So you can please go to the link kahoot.it. So please go to kahoot.it. Very simple to join, or you can scan the QR code. You can also do it this way and just enter the game pin, all of you. Just enter the game pin, go to kahoot.it, enter the game pin that you're able to see, and that way you can join, or you can just directly enter in this link and this way also you can join. So both ways you can join. I'll just be waiting for all of you to join in. You can see it's waiting for players. Anak Shah is the first one to join. Okay. Let's have all of you in here. You can just click on the link directly that I pinged you, and that way you can join the Kahoot quiz, everybody. And once everybody joins, I'll quickly start the quiz. Guys, quickly, I'm just going to count to 30 seconds to 40 seconds. I'll going to quickly launch. Wait for 30 seconds and join. Okay, great to see all of you in. Prasad, Prince, Aisha, Sai, Aziz, Prasad. Others, how are the rest of you? We've got quite a lot of folks in. We have 7 people who have joined right now. Others, I'll just count to another 30, 40 seconds max and if people are facing any difficulty joining, I hope not. So you can just directly click on the link and you can join. In the meantime, the team has also shared a feedback form. You can also just kindly fill up the feedback form as well in the meantime after you complete the quiz. Vivek, yeah, please tell me. Vivek, you have joined. I don't see you, Vivek. Okay, guys, there's a time limit. Okay, so I think we have to. I'm just going to wait for another 10 seconds here. So all of you, please try to join in quickly because we have to start the quiz. Because there's a time limit here. Okay. 10 of you, 11 of you, Raju. Okay, I think I'm just waiting for 3 more folks to join. Okay, 10 seconds, 10, 9, 8, 7, 6. I have to start posts. 4, 3, 2, 1. Vivek, you're there. I just wanted to wait for Vivek once because he pinged actually. Vivek, have you joined or should I wait for you? Okay, Vivek, fine. I think we'll start on. Okay, let's get going. The people who have joined in on time, let's get going. This is the first of the questions that's going to come up. You get a series of options and you have to pick up the best one. So all of you, all the best. So all our machine learning algorithms, I think this might be a little tricky, a little technical. So let's see how people are answering. Which one is the most complex algorithm actually? Other ones are, I think, pretty basic, but out of which one is the most complex one? Time's almost up. All right. So 7 of you have answered linear regression. I can understand because that is the one I actually taught you a little bit more in detail. I did not actually teach you linear regression. I intended to actually talk about regression in the session. You're actually correct. Linear regression is the kind of a regression algorithm. Even random forest and decision trees can be used for regression, but the answer is neural networks. Neural networks are an entirely different topic. Technically, it's a different thing, but the idea is that it's a very complex algorithm. Okay, so so all these 4 algorithms can be used for neural networks for regression, but out of which neural networks are basically able to model more complex patterns of your data, right? Yeah. Okay, so we have Aziz who is leading. Others, I think, got it incorrectly. That's okay. You have time to make it up for the rest of the questions. I'm confident this was a difficult one. Rest people will be able to do it. Let's see. A slightly tricky question. Look at the options and try to eliminate the incorrect ones. Okay, time's almost up. All right. All of you have mentioned all of the above. I can understand why that answer came in. But that's why I say it's a bit of a tricky question. I think there were, but then all of the above is probably because you thought that all are correct. But the answer, the question is specifically with respect to model performance. So we built a model y equal to x plus 1, and we are trying to understand if that's an accurate model or not. And the only way, and the primary purpose of knowing that is to figure out how accurate is the model in predicting the performance. Determining the optimal algorithm, maybe not so much, because that is where we are trying out multiple models, and feature selection is a different thing. That's where you're trying to figure out which of the features are important. Out of x1, x2, x3, are we going to take all the features? Is weather an important factor in predicting player performance? That is a different problem.
But why do we need to calculate model performance? Why do we need to calculate accuracy, precision, recall, these kind of things? Because we want to figure out how accurately it is able to predict player performance. So I think it's a bit of a tricky thing in terms of options. Aziz is still leading. Good to see. Yes, we have Shraddha. Mahendra has moved. Shraddha has moved up. Others, see if we can pick up, if we can catch up the pace. Okay, I think I can. This is again a bit of a tricky one. Bit of a tricky one, I can see. Yeah. विवेक सेशन सभी एक्चुअली बहुत लोग ज्वाइन करते हैं, तो क्या होता है हमें बीच में बात करनी पड़ती है, तो समझ में नहीं आएगा, नहीं तो वो बाकी जगह से ज्वाइन करते हैं, तो we try to keep it in English, but definitely so gradient boosting is the answer actually. Again, it's a bit of a tricky question. So again, maybe the options were a little vague, I would say. So it is between these two. काफी technical question था ये, but then it's okay. Even if people got it wrong, it's okay, expected. क्योंकि it is between these two, I would say. Both are ensemble learning methods. Gradient boosting, random forest, both are equivalent options, I can say. But the other two kind of are basic algorithms. So it's a slightly technical question, and something again that is, we were just testing you a little out of the bounds of the content today. So we have Aziz who is still leading. Prince has also moved up in the rankings. Good. Let's see. Yes, absolutely. The counselor and the team will again reach out to you. I'll just take another 2 minutes of your time and hand it over to the counselor. We will do that. Yes. Okay. Again, 3 of you have answered correctly. Identify and select the relevant points. Data points. Optimize theme selection and predicting player performance are actually modeling questions. But here the part is basically right at the initial stage of the data science life cycle, where we are trying to select the best data, and data ingestion is what we are doing. So that is something that we are doing only to identify the relevant data points. Just like Walmart, we are trying to figure out sales data, weather data, macroeconomic data. It's framing the problem and identifying what features we will use to solve the problem, not the other parts. Modeling part comes only much later in the whole data science life cycle, if you recall. Again, it was a slightly tricky question. Mahendra has moved up quite a bit. Prasad has moved up quite a bit. Prince has moved up. Aziz has dropped down. Shraddha has dropped down. Let's see. Last question. And we do this kind of simulation a lot in our classes also. I think it's very fun kind of thing. Yeah. All right. 5 of you have answered this one. Mostly people have answered correctly. And let's look at the final scores. We have Prince leading. Prasad is at a second and Aziz is at a third. Wonderful. Thank you, guys. Thank you so much for having me in the audience. Thanks for being a wonderful audience. And from here onwards, I'll be passing it over to the team. And the team will be talking about AlmaBetter and how we do our classes, what is our program. And some of the things you actually saw today in the class, how we took a lot of use cases and how we use the Kahoot quizzes is something we do a lot in our real-time sessions also. It's a very different program compared to what is generally offered. And we'll have the team who will walk you through aspects of the program and any questions you have with respect to the AlmaBetter course and how it is different, how it is so unique. We have the team who will give you further guidance on this thing from here onwards. Yeah. So all of you, please stay back. There's a lot more interesting things going to be talked about for another 10 minutes or so. Yeah. Over to you, team. Rashmi. Yeah.
Hi, Sayan. Thank you so much for taking out the time to do this session with us. It was really insightful. I hope the audience were able to get an idea on how the background of Dream11 works and how a lot of effects of the machine learning technique, like you showed us the use cases for machine learning on different platforms, and it was really great to have some idea on these things. So guys, I'll just take 5 to 10 more minutes of your time just to let you, just to give you a sneak peek on how do we do classes over here at AlmaBetter. So Sayan is one of our instructors and mentors at AlmaBetter, and like we conduct day-to-day live classes, and you'll definitely get to interact with people like industry experts like Sayan on an everyday basis. So just give me 1 second. I'll share my screen and I'll give you an idea on how do we do things here at AlmaBetter. I hope my screen is visible, right?
Yes, it's visible.
Cool, then we'll get started. So like you all must have seen either on the website or while you were signing up for this event, you must have seen that AlmaBetter is a community first platform. So what I mean by community first platform is that we keep students at the center of all of the events and activities that we do over here. The entire course is designed in such a manner so that students who spend their 6 to 8 months or roughly 6 to 7 months over here going through the learning processes are able to make the best out of the entire learning journey and are industry ready once they complete the entire learning experience, keeping in mind that students need real-time, job relevant skills or industry relevant skills to perform the best once they are ready for the company placements. So to foster that, we conduct these study sessions or the live classes that happen over here goes in a cohort. So right after you enroll in a program, you would be made a part of a group that would consist of 5 more folks who are similar like you, like-minded people group here together. So the entire learning experience will be in groups. You will be studying in groups. You will be doing a lot of group activities together. You will be doing you'll be doing projects and all. The capstone projects that you will be doing end to end will be done in a team of 5 people, like I mentioned, so that you have some experience or you have this simulation of how do you do projects while you are working in a company. You collaborate with a lot of people from a lot of other departments. So likewise, you'll be collaborating with other people over here to get your projects done, and you will be getting ready for jobs, and that too definitely will be an outcome of peer-to-peer learning, which will make you become better on an everyday basis. And that also helps in staying consistent throughout the course and for keeping up the motivation throughout the journey. So definitely, if you have folks with you who are going through the same journey, it pushes you much more to come to the finish line, to reach the finish line. The next part that I wanted to talk about is like why AlmaBetter? Why should you be enrolling at AlmaBetter? Because there are multiple companies in the market right now who might be offering more or less the similar propositions that we have in place. So AlmaBetter stands out because we have industry relevant curriculum that we offer to you, and we teach everything from scratch. Like if you are starting your journey here at day 0, if you have no experience in machine learning, Python, or if you don't have any idea about the data science domain or the development domain, but per se data science domain, then you do not need to worry about it. Like we will be covering everything from the very basics level, and we'll be progressing to the advanced concepts. The next part is that we offer 100+ live classes, and the access to the recorded lectures, the live recorded lectures would be there on your dashboard for a lifetime. So that access won't be revoked. We do 20+ capstone projects, and along with that, we give you 1,000+ coding problems. So you have that in abundance. You will never run out of quizzes to go through or the problems to solve, and that will keep you engaged and hooked throughout the entire course. We have weekly doubt resolution sessions, and we offer one-on-one mentorship sessions. So these sessions are really crucial, as in they help you give a personalized approach to where you need to work and how do you need to overcome the shortcomings that you're facing in the program. We have 50+ mock interviews, and we will also be providing you with a dedicated career coach once you reach our placement drive. So this will help you prepare, and this will help you finally groom yourself to present yourself in the company interviews when you reach at that place, when you reach the placement drive. And to top it all off, we have 100% placement guarantee, and we have 500 hiring, about 600 hiring partners in place who would be offering you placements once you complete the course. So once you enroll in the program, and you just need to focus on being consistent throughout the course. You do not need to worry about getting a placement. That is a tension that is left on the AlmaBetter team. We will be helping you out end to end in the placements. You just need to stay dedicated towards the course and do what is expected out of you to stay consistent. That's all. Next is the AlmaBetter path to success. So this is pretty straightforward, as in you need to sign up and enroll in the course. So That is all that you need to do. And you will be asked to pay a nominal admissions fee in process to make an enrollment. So we take this admissions fee because we want you to have some skin in the game, because if you do not pay anything, you might as well like enroll today and leave the course tomorrow, because you have not invested anything. You're not bound to stay consistent or put your efforts into the course. But if you are paying something, you will definitely have that responsibility that you have made a payment and you have to stick to it. So for that reason, we charge a nominal refundable admissions fee in the beginning. And I'll tell you like when will you get that refunded. So you sign up and enroll and pay a nominal admissions fee. After that, you go through the entire learning process that we have laid out for you. The learning process will consist of about 5 to 6 modules in the data science course. So for completing the course, you need to do one capstone project and one competency challenge in order for us to assess your learning for that particular module. So in total, let's suppose we have 6 modules. So we will be going through 6 capstone projects, one for each module, and 6 competency challenges, one for each module. So that we know that theoretically and practically, you have completed the module and now you're ready for moving ahead in the learning journey. That is for coming to the placement drive. So once we see that you have done these 2 qualifiers, means you have checked these 2 qualifiers for completing the course, you will be getting the certificate of program completion. And on top of it, you'll also be getting a certificate for completing each module, so that you become highly employable right after completing every milestones, like every modules that we have set for you. So once you complete the course and get certified as a data scientist, or you get the AlmaBetter program completion certificate, that is when you become eligible for getting into the placement drive. So over here, learning and placements are 2 different things. So once you become eligible for the placement drive, the AlmaBetter team will reach out to you and they would urge you to sign the income share agreement with us, which basically states that now your placement would be 100% guaranteed from our end and you will not need to worry about the placements. So we will be taking the entire responsibility of getting you placed. So by signing the income share agreement with us, you will be given the guarantee that now your placement is 100% guaranteed, like I mentioned. And in return, you will be paying us only after you get a placement of minimum 5 LPA. That is like once you start earning, only then you will be paying us the tuition fee. So that is how we effectively make it a pay after placement. And at this point, we would be refunding you the initial admissions deposit that you have made for the program. So that money will be refunded to you and it would effectively become a pay after placement. And once you have signed the income share agreement with us and came into the placement drive, so that is where your placement preparation begins. So 50 plus mock interviews and having a dedicated career coach and stuff that I was talking about earlier would be given to you at this point in time in your learning journey. And going through the placement drive for another 6 to 8 weeks, you will be harnessing yourself for becoming placement ready for, you will be becoming job ready for final company interviews. And once we get a go ahead from your dedicated career coach from the placement drive or your mentor that now this candidate is highly proficient for the final company interviews, we start sharing your profiles with our hiring partners, post which you get multiple job offers in your hand. And this is the last step wherein you get the, you finally get the placement and you start earning, and that is when you pay us back. So this was the straightforward end-to-end path to success through AlmaBetter. Next is the learning activities. So for technical skills, we conduct live classes, like 100% live classes that I already mentioned earlier. We have lab experiments. So lab experiments basically will help you visualize a problem, like for mathematics or for some other tough concepts where you cannot imagine everything. So you will be coming to the lab experiments and you will visualize things and you will go ahead with the topic. We have hundreds of projects and assignments. So after every topic that you go through, you will be getting a project and an assignment for you to complete. And we do a lot of group discussions so that you stay motivated and you stay active throughout the course. For motivation and industry exposure, we conduct one-on-one mentorship sessions. We have a lot of guest lectures. So like the masterclass that we have right now ongoing, we conduct a lot of guest lectures so that you get some industry exposure, sort of vast industry exposure throughout your learning journey. And we also have a lot of community participation so that you can network and you can build your connection with people. Mandatory for Alma X, we have capstone projects and competency challenges. Like I mentioned in the earlier path to success wala slide, that you have to check out these 2 qualifiers for becoming eligible for our placement drive. Next up is the salary distribution of AlmaBetter graduates. So like I mentioned that we have a minimum placement guarantee of 5 LPA. But as you can see, about 25% of the students, about 1/4 of the, 2/5 of the students at AlmaBetter About 40% of the students over here get a minimum placement guarantee of, sorry, not a placement guarantee, but they bag a minimum package of 8 to 9 LPA. So you can see that what to say, about 50% of our students get a placement of 8 to 10 LPA. So this is the number that you can easily focus on. And if you're consistent throughout the course, if you track your interviews quite well, you'll definitely have a say in the negotiation and you can get a good salary, because this domain is the highest paying domain right now if you are a fresher. Like the salary over here is thoda, what to say, massive, because the openings are high and the supply side is quite low in this very domain. Meet your instructors and mentors. So everybody that you interact with over here throughout your learning journey is already an industry professional, is already working in some or the other firm. So think about the exposure that you will be getting, the what to say, the materials or the things that the instructors would be discussing in the classes would be directly relevant to what they are doing in their day-to-day life. So your entire learning experience would be phenomenal because you will be learning from the industry experts themselves. Next up is the success story. So we have been able to place about thousands of students so far since the inception of AlmaBetter. So you can definitely get in touch with them and you can connect with them through the website, through almabetter.com. You can look at the profiles of the students and you can connect with them over LinkedIn and you can have a word with them in order to get an idea how they were able to transform their career. So there have been plenty of students who came from a non-technical background or a non-relevant background, and they were able to transform their career in the data science domain just because they had that conviction, that they have to switch their career or they have to do something in the data science domain, and they were able to do it. So the program that we have laid out is tried and tested, is supposed to bring out the outcome. So definitely there is no doubt that you will not be able to do it. Now, next up is the AlmaBetter dashboard walkthrough. I'll just take 2 to 3 more minutes in order to give you a sneak peek into how your dashboard would look like once you enroll in the program. Just give me 1 second, guys. I hope my screen is visible again, right? So once you enroll in the program, this is how your dashboard would look like. So over here, we have 6 to 7 categories. So first is the home. Home would consist of all of the things that are there on your dashboard at one place. Next up is the Learn tab. So through Learn tab, all of the learning resources and materials that you need to resort to is given on under one tab. You do not need to hover to or scroll over to other tabs for scouting for learning materials and having a look at the lectures and stuff. So like I mentioned that this program is consisting of 6 to 7 modules. So over here you can see that this is program orientation is basically module 0. You do not consider this. The first module that you would be going through is introduction to computer programming. So you'll be learning basics of Python. Like the lecture should be starting from the very basics of Python, and then we would be advancing towards the advanced concepts of Python. The next module is numerical programming in Python. After that, you will be learning about databases. You will be learning about tables, SQL, Excel, and all of the visualization tools that you need for dashboarding and stuff. The other module is visualization tools. So here you will be learning more about Power BI and Excel. The 6th module is applied statistics. So this is where you will be learning mathematics that is relevant for data science. And the last module is machine learning. So introduction to machine learning. So this topic will start from very scratch. You will be learning about the machine learning algorithms, and then we'll be advancing towards the supervised and unsupervised machine learning. And after that, we offer you 3 specializations. So after you have completed the first 6 modules, the basic modules, you will more or less have an idea that what do you want to get specialized in, what do you want to learn more deeply. So this specialization is basically optional. So right after completing up till machine learning, you become employable. You will be eligible for getting into the placement drive, and you will be job ready. Like you will be ready so that you can get in a company and you can start doing some work. You will be that eligible after completing the first 6 modules. But on top of it, if you want to have some advanced, if you want to learn some advanced concepts, and if you want to go to a senior level position, then for that as well, we offer you 3 specializations, and you can pick any one of these 3 specializations, spend another 2 months in the learning journey, and then come to the placement drive. So that feature is also available for you. So this is the Learn tab from where you will be getting all of the learning resources and materials available to you at one place. So if you are enrolling in the program, on the day of the program orientation, you will learn about all of this in more detail. I'm just giving you a sneak peek into what will be offered to you. Over here, next is the classroom tab. So for the live lectures that you will be getting, so you'll have the schedule of the live lectures over here on your dashboard. So on the day of the live class, like next class over here on my dashboard is on 8th May, that is tomorrow. So I'll get this link for joining the class once the like an hour or two before the class is going to commence. I'll be able to see that who is going to be instructor for this class, and after the class is completed, I'll be able to get the class lecture recording right over here on my dashboard so that I can review the recording. Likewise, you will be getting the recording for all of the lectures, and you will be able to see who was the instructor in that class and everything on at one place over here on your dashboard. Next up is the practice tab. So like I mentioned, you will be getting thousands of coding problems and everything on your dashboard so that you do not stay free, you stay involved and engaged throughout the course. So that is over here. You get coding assessments, quiz assessments, and everything that is relevant to it. You'll be going through 50 plus capstone projects. So over here, like about 6 to 7 projects will be mandatory in nature. So that is what you will be doing from here. For every topic, you will be getting plenty of options to pick from, like you can see on your dashboard, and that is how you will be good to go for the program. Next is the career tab. So as you go through the program, as you surf through the program, you will be making progress, you will be completing lessons and everything. So that is how you will be seeing that how far or how close you are to reaching Alma X. So right now my dashboard is quite empty. I haven't done any of the activities. So it is showing as 0% eligibility for Alma X. But as soon as you make progress and as soon as you keep learning and you keep completing the projects and stuff, this bar will go ahead and you will see that how close you are to reaching AlmaBetter. Next up is the mentorship tab. Like I mentioned, that you will be getting the feature of one-on-one mentorship session. So you can do that, like you can book a mentorship session from you. Like let's suppose if you want to have a data science professional guidance, you can choose that what topic do you want to discuss with your mentor, and likewise you can go ahead with it. And last up over here is the help desk. So putting together all of these features that we are providing to our students, we believe that this is enough for anyone to go through the learning process. And if you are consistent by just doing this, you will be able to complete the course and reach our placement drive. And last up over here is help desk. So through this, you can raise your doubts, issues, anything that you want to throughout your course. You can submit a ticket for any issues that you're facing, and our team will get back to you within 30 minutes to a day. So that is our TAD, even within a few minutes, if you're doing it in the working hours. So that is all that I had to show you about the dashboard. Now, like a sweet surprise that I talked about before. So since we have a new batch that is going to come on 9th of May, that is coming Tuesday. So we have an early bird discount going on right now, and the discount coupon, like I'll be giving you a discount of 35%. So that you can avail a discount and you can go ahead and enroll in the program. So you can use the coupon code Dream35 on the checkout of the data science page, and you can avail a flat discount of 10,500 in order to enroll for the program. So if you go on the checkout page right now, a coupon of 20% would be auto applied over there. You can remove that coupon code and you can use this discount code Dream35 in order to go ahead and enroll in the program. Are we able to see other progress in class? Yes, definitely. There will be a performance dashboard. Let me show that to you quickly, from where you can look at the performance of yourself and your peers from the dashboard. Yeah, so here is the performance tab. So from here you can see the module progress. So it is for your progress and this is for your cohort's progress. So since I have not been doing much of the activities on this dashboard, it looks quite empty. But when you go ahead with the program, this dashboard would look a lot more colorful, because you'll be seeing the progress of yourself and your cohort that is going on along with you. Do we have any more questions? Because I know that we are already past time of this masterclass, and I do not want to take any more time of yours. So if you have any issues or if you have any queries, I would urge you to fill out the feedback form. Narendra, could you please share the feedback form once again in the chat so that students can fill out if they want to have a call back from us? So Shraddha, the entire course fee is 2,40,000, but that is a pay after placement. Only after you're getting the 100% placement from us and you start earning. In the initial phase for enrollment, the price is 29,999, on which we are offering a 35% discount. So the final payable would be around 19,500. That is what you pay right now for enrolling in the course, and you will get that fee refunded when you reach the placement drive, which is optional in nature. If you want, if you have studied the course, if you have completed the entire course and you feel that now you can get the placements on my own, you can very well go ahead and do that. In that case, we won't be charging you the pay after placement fee. In that, the initial deposit that you have paid would be all for the program. But if you opt for the placement drive with us, wherein we guarantee you a minimum salary of 5 LPA, so you will be paying us the fee only after you get the placement in your hand and you start earning. Cam, the total live class hours is the entire course is for around 300 to 350 hours. So in 350 hours, you'll be able to complete the entire course. So this course is for 6 months. So guys, if you do not have any more questions, I would urge you to fill out the feedback form that Narendra has just shared over the chat, and that would be all for you. And you definitely need you to fill out the feedback form, at least for those students who have participated and won the positions in the quiz, so that we can get back to you and we can give you the amazing gift vouchers that we talked about in the beginning. All right, so yeah, you can click on the link of the feedback form. Let me share that again with you over here, so that even if this meeting has ended, you can still fill out the feedback form. Just one second. Yeah, so you can click on this link to fill out the feedback form. I would definitely urge you all to fill out the feedback form so that we can improve in the further masterclasses, and see you in the next week's masterclass. Thank you everyone for taking out the time and joining in. Thank you.